जी सर. Hello, good evening everyone. Lot of you are already there. Ankit, Vipul, Kajal, Darshan, Meera, Onam, Lekhya, Ankit, Aman, Krishi, Manas. Good evening everyone. Good evening. Please confirm, am I audible properly? Are you able to hear me properly? Excellent, Ridhima. Thanks, Ashmit, Vipul, Chandana. Thanks for confirming. Okay. So, yes, you are seeing me after a lot of time, some of you. So, all of you are ready for today's mathematical adventurous extravaganza. And we are going to discuss everything about time, speed, and distance, all about TSD in CAT Quant. Yes, I can see Kumar Akash from batch 1, and there are many others also, I think, from batch 1 and some from batch 2 as well. Basically, this is the first class of pre-batch for our last batch of our CAT 2024. So if you have not yet enrolled, so you still have a chance to enroll for iQuanta, the prestigious course for CAT preparation. This is the last batch, and your course will be over by the first week of October. I'm just mentioning little bit details of this last batch. The batch is already started. This is a sort of first class. This is a pre-class. Your main classes will be starting from the first or second week of July, and your pre-classes are scheduled from this very first class only. So your course will be over by first week of October. After that, you'll be having about 2 months of complete crash course, and there will be around 35 mock tests and a lot of sectional tests. All this information is useful for our previous batch students as well. So that's why I'm repeating the same thing. Okay, so yes, we'll use English primarily, of course, Karthi, Krishna. Okay, what basics we should study for the last batch? Disha is asking. So Disha, everything will be taught in your batches. So whatever is required for your CAT preparation, that will be there. And other than live classes, you are going to have application classes, practice classes. There are non-engineering conceptual videos. Similarly, English for English preparation, you are having special engineers VARC sessions also. So there are a lot of things. So everything will be there. Aishani says TSD का थोड़ा revision भी concept wise. Yes, we are going to revise. We are going to discuss all the concepts of time, speed, and distance, Aishani. Okay. So let's start. We have another student from first batch. Yes, Deep, your reporting have been testified. Okay, so let's start now. Ready, everyone? So you are going to discuss the concepts in brief, and then we are going to apply it in questions. Okay? Welcome, Manish. So let's start now. So as you all know, the topic is time, speed, and distance. Aditya, for this last batch, we are having around 2.5 months of regular classes. After that, There will be 2 months about crash course. So in all, there will be around 4 to 5 months of live classes other than your self-study. Fine. Okay. So let's start now. So topic is time, speed and distance. And the beauty of this topic is that it's very simple. And in every CAT paper, you are going to get questions from this topic for sure. At least one or sometimes two. And in some CAT papers, you can find more than 2 questions as well. But in general, 1 to 2 questions are certainly there. And sometimes in CAT, this time, speed, distance topic has been used in your LRDA section as well. That means 4 questions from this topic. Fine. So this is a very basic topic and it is an important integral part of your arithmetic, which you know constitute most of the questions of your CAT Quant. Fine. So the easiest part about this topic is the relation between these 3 terms, time, speed and distance. Can you write in the comments what is the relation between these 3 terms? By the way, let me tell you this, you have studied the relation between these 3 terms in your class 6. Please tell me the relation between these 3 terms. What is the relation between time, speed and distance? Harshita, this session is on YouTube only, not on FB. Okay, I can see Samiksha, Manan, Vipul, Megha, Deep, Ankit. A lot of you are mentioning that. Excellent. That's perfectly fine. That distance is equal to speed into time. If I refer D as distance, S as speed and T as time, so distance is equal to speed into time, or we can also write as speed is equal to distance upon time, or we can also say time equals distance by speed. That's it. So if we are familiar, if we are convinced about this relation between these 3 terms, then most of our questions regarding this topic are very basic, very clear. There is no difficulty at all. There is nothing more about this. Everything other than this is just specific cases. So that is the most basic part of this topic, time, speed and distance. That distance is speed into time, or speed is distance upon speed and time is distance upon speed. And a very easy way to remember this is this triangle. If you make a triangle, just divide it in 3 parts as I have done here. So if I write D in this top triangle and S and T in the bottom 2 parts here, so this triangle tells us all of these relations. That distance is equal to speed multiplied with time. Fine. And similarly, speed, if you see, the speed is equal to distance upon time. And similarly, this time is equal to distance upon speed. And all these 3 relations we have already mentioned here. Fine. So that's an easier way to remember the correct relation without confusing. Right? Without getting confused, we just can recall all the 3 relations from this thing. Okay, next part. What are the units for speed? The common units for speed are meter per second or kilometer per hour. So these are the 2 common units we use for speed in all of our questions. Fine. So now quickly tell me, is 1 kilometer per hour equal to 1 meter per second? I repeat, is 1 kilometer per hour equal to 1 meter per second? Certainly not. Kilometer and meter, they are not same. Hour and second, they are not same. So how to convert a kilometer per hour in meter per second? That's my question. 1 kilometer per hour equals to how much meter per second? Because a lot of times we need to use that. Thanks for pointing this error. It was S equals to distance upon time. Speed equals to distance upon time. Yes, it is 5 by 18 meter per second. See, 1 kilometer, if we convert in meters, it is 1000, right? And 1 hour, if you convert it into seconds, that is 3600 seconds. And on simplification, you can see 2 zeros are cancelled, 2 5s are 10, and 2 18s are 36. That makes it 5 by 18 meter per second. So that is a conversion, and you just multiply throughout by 18, you will get 18 kilometer per hour equals 5 meter per second. Fine. So that's an easier or handy way to remember the relation between the two units, kilometer per hour and meter per second. 18 kilometer per hour is equal to 5 meter per second, and their multiples. Fine. Okay, that is just a basic introduction about what is time, speed and distance. So that's the basic introduction. Now let's move further. Is it fine so far? Shall we proceed? Okay. Before I move to the next topic here, that is proportionality, before that, I take a small question. Please answer this question quickly. A car traveling at 90 kilometer per hour met with an accident how far it was from the point of accident four seconds ago. Please answer this question fast. Excellent. I'm seeing a lot of questions. Wonderful. It is 100 meter. Pratik, you have typed 52 times or 3 times. See, that was very basic question, just application of the relation between time, speed and distance. See, the car is traveling at a speed of 90 kilometer per hour. So speed is known to us. It is 90 kilometer per hour. That is speed of the car. And it met with an accident. Question is how far it was. How far? That means the distance is being asked about. Fine, we need to find the distance. And what is the time? So time is how far it was from the point of accident 4 seconds ago. So this is the time given. Right? So time is 4 seconds. That means the car met with an accident. So before 4 seconds, if you rewind the whole scenario, so before 4 seconds ago, you rewind the scenario. So the car which was moving to the point of accident, now let's take it back, 4 seconds back. So when it is going back for 4 seconds, so it is traveling with the same speed, and it is traveling back for how much time? 4 seconds, isn't it? So our speed is 90 kilometer per hour, time is 4 seconds. Question is to calculate about the distance, and you know that distance is nothing but speed into time. But can we directly multiply 90 and 4? No. Right? No, we cannot multiply directly 90 and 4. What is the reason? Units. So here it is kilometer per hour and here it is seconds. Isn't it? So we need to convert this 90 kilometer per hour into meter per second first. Exactly, that is perfectly fine, Kashish. So every second car is moving 25 meter. Good. So first we need to see that this 90 kilometer per hour equals to 25 meter per second. See, we just saw in the previous part that 18 kilometer per hour equals 5 meter per second. Isn't it? So 90 kilometer per hour means we just need to multiply by 5. So speed is 25 meter per second and time is 4 seconds. So if you multiply, you will get your answer as 100 meter. Fine? Is it okay? See, time speed distance is very interesting thing if you are able to visualize what is happening. If you don't try to visualize, if you just try to use the formula, you are going to get stumbled. You're going to get a fumble again and again. But if you understand what is happening, as I just mentioned in this case, a car was traveling and met with an accident. So just rewind the scenario. So car is going back at same speed and for 4 seconds. So that distance we needed to calculate. Fine. And the only difficulty in this question was to change the units, right? So converting the units and we can find our answer. Okay, let's move further now. So these are the basic variety of questions in which out of D, S and T, 2 things are given to us and we have to find the value of the third one. ठीक है ना? So as in this question, speed and time were mentioned, we were to calculate the value of D. There can be some other scenarios in which other 2 things are mentioned and you have to find the third one. Now there are one important variety of questions in which only one thing is mentioned and in other thing is being talked about, other thing is being asked about, and the third thing is not mentioned at all, So how to solve that variety of questions? So in that case, this proportionality comes into picture. So now we are going to talk about this. Fine. Yes, this class will be available there on YouTube, Prachurya. It's very easy, basic concept. You can repeat it afterwards. We are going to cover a lot of things. So let's move further now. Now we are going to talk about proportionality. And if there is any difficulty, I certainly recommend our team members here and our past students also to help each other. Fine? Okay, so now what does this proportionality means? So proportionality means, as we saw, that distance equals to speed into time. So if one of the thing is constant, then other 2 terms becomes proportional to each other. So there are 3 cases possible. First case, the distance is constant. If distance to be traveled is constant, fine. If distance to be traveled is constant, Diksha, we just mentioned that 18 kilometer per hour equals to 5 meter per second. We calculated that, isn't it? Now, if 18 kilometer per hour is 5 meter per second, then what about 90 kilometer per hour? It is simply 5 times of 18, isn't it? So similarly, it is also going to be 5 times. That means 25 meter per second. That's it. Isn't it? Okay. So if distance is constant, so what is going to be the relation between S and T? So their product is going to be constant. So speed 1 and time 1, their product will be equal to S2 T2, or we can also say speed is inversely proportional to time. Fine. Now think and answer me. To travel a certain distance, if I double my speed, I repeat, if I double my speed, what will happen to the time taken? How much time will be needed now? If I double my speed, what will happen? I will take more time or less time? Half the time, exactly, because I have doubled the speed, so time taken will reduce to half. If I make my speed 4 times of usual, then time taken will reduce to 1/4, isn't it? That is the meaning of this part, that speed and time are inversely proportional. So basically, if distance to be traveled is constant, I need to travel the same distance, right, from one particular place to another particular place. So if I change my speed, then my time will also change accordingly in the inverse ratio, right? So as we have just given an example, if speed gets doubled, then time will become half, and so on. So speed and time are inversely proportional, or we can also say that speed into time will remain constant. S1 T1 equals S2 T2. Fine. So this is one of the proportionality. Second variety of proportionality is that if time to taken is constant, if time taken is constant, so if there are two moving objects, they are traveling for same duration of time. I repeat, they are traveling for same duration of time. What will happen? Will they travel same distance? It depends upon their speed. So if t is constant, in that case d upon s will become constant. So I should write d1 upon s1 will be equal to d2 upon s2, or we can say d will be directly proportional to s. Distance will be directly proportional to speed, because you two moving objects are traveling for same duration of time. So the one who is having more speed will travel more distance, isn't it? The who is having less speed will travel less distance. So that's the second particular case of proportionality, when time taken is constant. Is it okay? And we are going to solve questions based on all of these. Till that it is fine? Yes. And similarly, the third case remaining, you can see it very easily now. What is third case remaining? D constant we have done, time constant we have done. The third one is speed is constant. So if a person or if a moving object is traveling with constant speed throughout, so what will happen if speed is constant? So more the distance to be traveled, more time is to be taken. So d by t, d1 by t1 will be equal to d2 by t2, or we can say that distance will be directly proportional to time taken. So these are the three possible cases of proportionality, but when they are to be applied, only if distance is constant or time is constant or speed is constant. So basically, if one of the three things is constant, in that case other two becomes proportional to each other. So we can solve the question faster by using that proportionality. Fine. Now we are going to apply this. Is it okay so far? So here is the question for you on your screen. Okay, time to answer this question now. If you're getting any ads in between, you can skip that. Paras, if distance is constant, so what will happen? Speed into time will remain constant, na? So speed was S1, time taken was T1. So distance was S1, T1. If you change your speed to S2, time will be changed to T2. So distance will remain same, S2 into T2. And they're going to remain constant. Okay, I'm getting two answers here. Some of you are saying A, some of you are saying D. Is it A or D? Okay, Manshi. 2, 3, 4. Abhishek, option D is none of these, not 2, 3, 6. 2, 3, 6 is there in the second option. Okay, let's check now how to solve this question. See, it says times taken by 3 sprinters to cover a race track are in the ratio 6:4:3. Before moving further, this is a question for everyone. Please listen carefully. I'm talking to you. Please tell me what is constant in this scenario. Time taken by 3 sprinters to cover a racetrack are in the ratio this much. There are 3 sprinters who are running a race, right? Who are running a race, and their time taken are in the ratio 6:4:3. So what is the constant parameter here? Which parameter is constant in this case? Please tell me. Is something constant here? Yes, distance, the racetrack, the track length of the racetrack, isn't it? That distance is constant because every one of them, these 3 sprinters, every one of them, each of them is traveling the same distance, right? But the time taken are different. They are in the ratio 6:4:3. So they are taking different times. What does it indicate? It clearly indicates their speeds are also different. Yes or no? Right? I repeat, listen carefully. In this scenario, question doesn't say that distance is constant. We need to infer that. We need to understand that. And if you are able to deduce that from this question statement, then it becomes very simple question. So time taken by 3 sprinters to cover a racetrack are in the ratio 6:4:3. So there are 3 sprinters, there are 3 runners who are running a racetrack, and to cover that racetrack, the time taken are in this ratio. So they are traveling same amount of distance. So distance is constant. Fine, which means speed into time will remain constant. Their timings are different, 6:4:3. The timings are in the ratio 6:4:3. So let's say first one had a speed S1 and it took time T1, and the second one must be having a different speed, maybe S2. So time taken was T2, and similarly S3 and T3, isn't it? So T1, T2, T3, they are given in the ratio 6:4:3. So question is, what will be the ratio of the speeds? We need to calculate the ratio of speeds. That means S1, S2, S3, at which they cover the distance. Okay, now I hope most of the part is already done. So how to proceed further now? What can you answer? How can you answer? See, there are 2 ways. If we don't use proportionality, if we solve it normally, logically, so what we can do is S1, T1, S2, T2, S3, T3, we know the values of T1, T2, T3. Let's say times are 6 units, 4 units and 3 units only. I can put that value directly. So it will be 6 times S1 is equal to 4 times S2 equals to 3 times S3, isn't it? So that is the distance. So let's assume the distance to be multiple of 6, 4 and 3. Can you tell me the lowest common multiple or LCM of 6, 4 and 3? What is the LCM of 6, 4 and 3? Yes, most of you are mentioning that already. Yes, so LCM ले लीजिए, that would be simple thing. So 6, 4, 3, LCM for them is 12, right? So LCM of 6, 4 and 3 is 12. So let's assume that distance is 12 units, isn't it? So from here directly we are going to get the values of S1, S2, S3, and that is going to be the ratios, right? So 6 S1 is 12, so S1 comes out to be 2. 4 S2 is 12, that means S2 comes out to be 3. And 3 S3 is 12, that means S3 comes out to be 4. So this is the required ratio, and that is our answer. Fine. See, so I have not used any formula or something. We are only using distance is equal to speed into time. And just by using the commonsensical part to make our calculations easier, we took the time to be 6, 4 and 3 units only. And similarly, we assume that distance to be LCM of these 3 numbers. So that speed comes out to be an integral values. Fine, that's it. We got our answer. Okay. How we can use proportionality here? How we can use proportionality here? See, we talked earlier that if distance is constant, then speed and time are inversely proportional. So whatever is the ratio of time taken, ratio of speeds would be inverse of that, right? It is given that T1 is to T2 is to T3 is 6 is to 4 is to 3. So I can say the ratio of speeds would be inverse of that. That means ratio of speeds S1, S2, S3 is going to be inverse of that. That is 1 by 6, 1 by 4, 1 by 3. Now we just need to simplify this. Right? We just need to simplify this, and to simplify this, it's again very easy. We can take the LCM 12. So if I multiply throughout by 12, I'm going to get my answer. So just multiply it by 12 to get the integral ratios, and we are going to get the same answer as we did as we got there. It is 2 is to 3 is to 4. So this is the required answer. Is it fine? Paras, we took LCM to make our calculations simpler. That's it. So wherever LCM can help us, you should take it. Okay, so let's move to the next one now. Okay, another question. Please answer fast. Now again, first tell me what is constant in this question. Is time constant here? Sharda, Ria, please think again. Many of you are writing time. Is time constant here? The difference in timings is given 30 minutes. How time can be constant? Yes, the distance is constant. See, they are covering a certain distance. That distance is constant here again. A certain distance is to be covered here. What is the answer, by the way? Yes, answer is 30 kilometers. Many of you have got that. Good. See, if the difference in the time taken, time is not same, time is different. It is clearly mentioned here, isn't it? The difference in time taken, so they are taking different times to cover a certain distance. That distance is certain. It is a fixed amount of distance at speed 10 kilometer per hour and 12 kilometer per hour. So speeds are also different. So there are different speeds and different time taken, isn't it? And the difference in the time taken is given 30 minutes. So the distance to be traveled, that is constant. So again, this is an example of constant distance scenario. So distance to be traveled is constant in this case, and so again speed into time will remain same. So initially speed was 10 and then speed was increased to 20, something like that. So the difference in time taken is 30 minutes. So based on this information, we need to calculate the distance in kilometers. So this is very basic question. If you don't apply any proportionality or something, you can make simple equations. So if in case of 10 kilometer per hour, let's say time taken was t hours. Let's assume that. Okay? So can you tell me what would be the time taken with a speed of 12 kilometer per hour? If time taken with speed of 10 kilometer per hour was t hours, so what would be the time taken with a speed of 12 kilometer per hour to travel the same distance? It's clearly mentioned, it is 30 minutes, there's a difference of 30 minutes. That means time taken would be 30 minutes less here or half an hour less here. So basically it will become t minus half hours, isn't it? Yes or no? Right? T minus 30 minutes, T minus half. Because we are writing in hours and speeds are also given in kilometer per hour. So we will prefer to use in hours only. The T minus 1 by 2 hours. So now simple equation. I'm not using any proportionality right now. Make simple equation. So distance means speed into time. The speed into time is going to remain constant. So when speed was 10, time taken was T. So 10 times T is equal to, when speed becomes 12, time taken becomes T minus half. And what this is nothing but the total distance which is being talked about. So just by solving these two equations, these two sides, we can find the value of T, and plug in that value of T again, we will get the value of D, which we have to find out. Isn't it? Let's simplify. So this is 10T equals 12T minus 6, which means this 6 equals to 12T minus 10T, that is 2T, or this T comes out to be 3 hours. Fine. Now this T is 3 hours, so 10 into T, that means 10 into 3, our answer becomes 30 kilometers. Fine. So I hope this is clear to everyone. This was a very basic part, very easy thing. We need to understand how to create an equation. Faktistan, it is not tattoo, it is tulsi beads. It's called kanthimala, neck beads. Okay, now let's see. Yes, how we can use proportionality. How we can use proportionality, now let's check that. See, as we have seen, the distance to be traveled is constant. That we have seen, the distance to be traveled is constant. So that means speed and time are going to be in inverse ratio. Here, ratio of speeds is 10 is to 12. Ratio of speeds S1 by S2 is 10 by 12. That is 5 by 6. Yes or no? Right? That is given part. So what about the ratio of time taken? That means what will be the ratio of T1 by T2? It should be nothing but inverse of that. That means in place of 5 by 6, it is going to be 6 by 5. Isn't it? That should be the ratio of time taken. Now it is mentioned here that difference between them is 30 minutes. That is half an hour. So if I assume T1 to be 6 hours, so T2 should be 5 hours, but difference is 1. I want to make this distance half, this difference of time taken to be half. That means the actual values are going to be T1 is 3, then T2 is 2.5 hours. So basically we got the exact values without solving anything. Right? Without solving anything, just by the ratio of speeds, we got to know the actual time taken in both the scenarios. So when S1 is 5, so T1 is 3. Isn't it? Did we do any mistakes? Oh, sorry, S1 is 10, sorry, not 5. So when speed is 10 kilometer per hour, in that case, time taken is 3. So as we did here, so 10 into 3, that will give you 30 kilometers. So that's our answer. So by using proportionality, we don't need to solve anything. We just use the ratios of speeds and time, and we can get our answer. Fine? So that's how we can save that much amount of time. Is it okay? Riddhima, which part is not clear? Please be specific. Yes, time difference is given 30 minutes. See it here? 30 minutes का मतलब half hour होता है ना? 30 minutes means 1 by 2 hour. Isn't it? So in first case, if time taken was T hours, then in second case with a speed of 12 km per hour, time taken is half hour less, that is T minus 1 by 2 hours. That's it. Manish Baba, time is given now. Time is taken is 30 minutes less when you increase the speed. So if initially time taken was T hours, so in the second case, time taken is T minus half hours. That's it. Okay. Good, good. I hope it is very clear to everyone. So if we have to make simple equations, that's very basic thing. As I have said in the beginning only, we just need to make use of the simple formula distance equals speed into time. That is a basic relation among these three terms. You make simple equations, solve the question, that's it. So if we are able to use proportionality, that makes the question even faster. Okay, so let's move now to the next question. Anand Gupta, kya samajh nahi aa raha? Be specific. If you will not tell, how will I get to know? Everything is mentioned here. We have discussed two different methods: make simple equation or use proportionality. That's a good point. Riddhima is asking T1 by T2, how you used 30 minutes. See, T1 by T2 comes out to be 6 by 5 because it is to be inverse of the ratio of speeds, isn't it? We know that speed and time are inversely proportional if distance is constant. When distance is constant, so speed and time are inversely proportional, right? So the ratio of two speeds is 5 by 6. So the ratio of corresponding time taken should be inverse of that, that is 6 by 5. So this was the first part. And from here I got to know that actual time taken should be 3 and 2.5, which is half of this. And how I got to know? Because I know that the difference between the timings is half an hour, 30 minutes. Is it okay, Riddhima? That was the point here. So the difference between the two timings is half an hour. So that's how I got to know the exact value of T1 and T2. So when speed was 10 km per hour, then time taken is 3 hours. And in the other case, when speed was 12 km per hour, time taken was 2.5. So whatever case you can use, so 10 into 3, that is 30, or 12.5 into 12 into 2.5, that is also 30. That is the distance. Okay, next question now. And here it is. That's a replica of actual CAT question. Please solve it fast. Aman, D was the distance. D cannot be 1 hour. Yes, 1000% is the answer given by many of you. Good. Sukalyan thinks 54.54%. Garima 10 times. 10 times more you mean to say. So that is same 1000% then. Yes, the same thing, 1000% or 10 times more. Okay, now everyone, please again try to see the statements and tell me what is the constant thing here. See, the best approach to for these time speed distance questions in which there is some storyline involved, it is always better to draw the diagram. whatever bad diagram, whatever how much bad you may be at drawing, but it's always better to visualize the situation, and to visualize it, it's better to draw it, right? So let's try to draw. So it says here a train approaches a tunnel AB. So there is a tunnel and a train is approaching the tunnel. Fine. Yes, time is a scenario which we are going to make use here. Let's see how. So first let's draw the diagram. So a train approaches a tunnel AB. So there is a tunnel. So let's say I'm making this as a tunnel. Let's call this as the tunnel. And its name is AB. Now a train approaches this tunnel. So train is somewhere here, let's say. This is train. And train is approaching this tunnel. Fine. So inside the tunnel, a tiger was sitting at a point that was 5 by 11 of the distance from the entrance A. So this is the entrance A and this is the exit B. So from the entrance, this lion is there, a tiger is there at a point which was 5 by 11 of the distance from the entrance A. That means if I assume this total tunnel length to be 11 units or 11x, so the position of tiger is at a distance of 5x from A, isn't it? So it was something like this. Let's say it may not look like exactly tiger, but assuming it is a tiger. Fine. Now this is the position of this tiger, or it looks like a cat, by the way. So 5x and this is 6x. Is it okay so far? Okay. So now the tiger is positioned at this place which is at the distance of 5x from A and 6x from B. Fine. So far we have plotted here. Now it says when the train whistles. So at this moment when train whistles, so let's assume this distance of train from this entrance is somewhat maybe D units. Okay. And this question appeared in actually CAT, I mentioned earlier also. It's a replica of actual CAT question. So in CAT question, in place of tiger, it was cat only. The values was different. But anyway, so now this is the distance 5x, 6x, and this distance is D. Now it says at this situation, when the train whistles, the tiger runs. So at this moment, train has whistled, and by hearing this whistle, the tiger starts running. Right? Now it says if the tiger moves to the entrance of tunnel A. Now tiger has only two options. Either it can move towards A or it can run towards the exit B. So it says if the tiger moves to the entrance of tunnel A, the train catches the tiger exactly at the entrance. Now this is a good situation. It is mentioned from this position now, if this tiger starts moving toward the entrance, tiger moves to the entrance of tunnel. That means tiger travels a distance of 5x units, isn't it? So in that same duration of time, what happens? The train catches the tiger exactly at the entrance. So train catches the tiger exactly at the entrance. That means in same duration of time, the train is able to travel the distance D units. Yes or no? Are you getting it? Piyush, it is 5 by 11 of the length of the tunnel only. What is the issue in that? This is 5 and this total is 11. So it is 5 by 11 of the tunnel's length, isn't it? Is it okay, Piyush? The tunnel length is 11x. Out of that, this is 5x. This is 5 by 11 of length of the tunnel from the entrance of the tunnel. That is mentioned here, isn't it? So it is the tiger was sitting at a point that was 5 by 11 of the distance from the entrance. Okay. Okay. So far it is clear. So from this position from this position, so the moment that this tiger moves towards the entrance, it travels a distance of 5x. Distance from A ही तो लिखा है बाबा, 5/11 of the distance. 5/11 of the distance. Which distance? Not this distance. It's the distance here refers to the length of the tunnel. The tiger was sitting at a point that was 5/11 of the distance from entrance A. It's 5/11 of the tunnel length. इस distance का 5/11 का क्या मतलब बनेगा? What is that? What does that mean? This 5/11 is the length of the tunnel. Okay. Okay. Now, so in this moment, when train this tiger reaches at entrance, the train also reaches at entrance. So what is common in these two movements? The distances are not same. The speeds also we are not sure about that. But what is same? The time taken is same, isn't it? The time taken is same for both of them. So that was the important point. I do not know whether D equal to 5x or not. We do not know that. That's why I have mentioned it separately. I have used the different variables for them. So, but we know that that when at this moment, let's say at this moment, that timing is 0, 0. So when tiger reaches at the entrance, what is the position of train? Train also reaches the entrance, isn't it? The train catches the tiger exactly at the entrance. It means time taken by both of them in this duration is same. For this particular journey, the time taken is same. Yes or no? So here time is constant. So time taken is constant. From this position up to when they both reach at the tunnel. That means when train reaches at entrance, the tiger also reaches at the entrance. Is it fine so far? Now, what happens when time is constant? So we have studied that if time is constant, then distance and speed are directly proportional. Distance and speed are directly proportional. We can say that the ratio of the distances traveled will give us the ratio of the speeds. So ratio of the speed of tiger, speed of let's say tiger to speed of tunnel, speed of train, sorry. So what will be this ratio? Speed of tiger to the speed of train. That will be in the ratio of the distances traveled by tiger to that of train. So distance traveled by tiger is 5x and distance traveled by train is d. That is going to be the ratio. Is it okay so far? Okay, now let's move further. So this was the first situation. Now second situation, it says ki if the tiger moves to the exit B, what happens if tiger moves to the exit B? So if tiger moves to the exit B, so tiger is to travel 6x unit distance and the train catches the tiger exactly at the exit. So same situation happens. Now train is to travel D plus 5x plus 6x. So that also happen in same time. Again, time is constant. So it is also equal to the ratio of speeds of tiger and train is also equal to the distance traveled by a train, that is 6x. And in that same duration of time, the train has traveled D plus 11x. Now you can easily solve them and find the required ratio. Isn't it? Please do it fast. Those who have not got the value yet, please simplify this and find this ratio of the speed of the two, tiger and the train. Please do it fast. Fast, please, fast. Get this value. Yes, it is coming out to be 66/6. That is 1/11 basically. Radhika, the ratio of speed is the ratio of distances. The ratio of the speed of the two runners here, tiger and the train, that is the ratio of the distances traveled. For the first scenario, the tiger has traveled 5x and the train has traveled d. So 5x by d is the ratio of speed of tiger and train. For the second running, so when tiger travels 6x, in same duration the train travels d plus 11x. So the ratio of the distances traveled will be the ratio of the speeds. That's how. And now simplifying this, we can find the ratio of their speeds. Yes, it comes out to be 1 by 11. If you simplify this, you can find the value of d in terms of x, and then finally this ratio comes out to be 1 upon 11. Yes, d comes out to be 55x. Thank you, Akanksha. Yes, d comes out to be 55x, and by substituting that, you will get the ratio of speed of tiger to speed of train to be 1 by 11. Fine. And now you can easily answer the question. Is it okay? Yes, 5 by 11 of tunnel length hona chahiye. I agree with that. If this distance from entrance A doesn't mean that this distance. Is distance ka 5 by 11 kaise karoge? What does that mean actually? This 5 by 11 of the tunnel length is 5 by 11 of the tunnel length. Let me mention here 5 by 11 of the tunnel length from entrance A. Fine. Okay, now let's see one more thing. Do we really need to solve this equation to get this value? It's not necessary. Let me repeat. It's not necessary to simplify this value to get to this answer. One way is to cross multiply and simplify. This is one of the ways that you can do. You have done that. But there is a better way. There is a better way of solving ratios. You just subtract the numerators and denominators. I repeat, just subtract the numerators and denominators. Tell me, if you will subtract this 5x from 6x, kitna aayega? 6x minus 5x, that is x. Yes or no? I'm just subtracting the two. Same way, subtract the denominators also. Subtract the numerators, that is x, and subtract the denominators, that is 11x. And that is your ratio 1 by 11. Fine. So that's a faster way, that's a better way to solve ratios. Okay. Yes, Anya, what's the name? Yes, Anya Gupta. That's what I have done. Other than cross multiplication, which is a basic method, you can directly do this part. Subtract the numerators as well as denominators. That's how you can solve it faster. Okay. Okay, now one more important thing. See, there is no need to write even this equation. We can do something better than that also. Everyone, please listen carefully. Yes, so 1 by 11 means the speed of the train is much more than that of speed of tiger. That's of course, yes. Abhay, that's why for this purpose only this class is being conducted. Okay, now see one more thing. Please tell me, can you tell me when train travels distance d, how much distance tiger can travel? Preeti, schedule time is till 9, but if required, we can extend it. Please answer it faster. Yes. The moment when train travels a distance of d units, in that same time, how much distance the tiger is traveling? Please tell me. X upon 11x can be simplified to get 1 by 11. Then 5x, right? So when train travels a distance of d units, the tiger travels 5x, right? Now 5x, if tiger moves in towards the tunnel entrance A, then also it will travel 5x. And if it is to move towards the exit B, then also it will travel 5x, right? So let me take the second scenario. When train has reached this position, When train has reached this position and traveled distance d, so in that duration, that tiger will travel a distance 5x here. So that means further now, the tiger is to travel only distance x units, while the train is to further travel a distance of 11x units. And we know that they are traveling that distance in the same time, isn't it? That's how we got the ratio of their speeds as 1/11. Fine. Yes, Deep, that's perfectly thing. Okay, so let's move further now. So let's quickly increase the pace. So we have done the basic part. What is the time space distance? What are the types of questions? And how to make use of proportionality in solving our questions easily. We can make simple equations, or we can make use of proportionality. And we in this question, we made use of the ratios as well. Okay. Okay, let's move further now. So now the next thing is average speed. Quickly, please tell me, what do you mean by average speed? What do you mean by average speed? So basically, average speed is that constant speed with which, if we travel the whole distance, we will take the same total time. See, practically, when we are traveling a certain distance, there is a certain distance, we may travel certain distance, let's say d1 with some other speed, and further distance with some other speed, and further distance with some other speed, and we can take the different timings also, isn't it? So average speed means in this duration we may have taken the time t1, here we may have taken time t2, here we may have taken time t3, and so on. So the average speed means that if we are to travel the same distance with a uniform speed, a constant speed, so that we take the same total time which we are taking presently. So that constant speed is known as average speed. Okay, I repeat again. If we are to travel the same total distance, that is d1 plus d2 plus d3 in this case, and we want it should be traveled in same time t1 plus t2 plus t3. So what will be that average speed? So that constant speed, that uniform speed is known as now average speed. So this is the same total distance, that is d1 plus d2 plus d3 upon the total time, that is t1 plus t2 plus t3 and so on. So this average speed is nothing but the constant speed which will help us to travel the same total distance in same total time. That's the basic thing. Fine, that is the only thing. Is it okay? Good. Now let's continue. So that this is a very basic thing, and many questions have been asked in CAT directly on the basis of average speed. So if you know what is the meaning of average speed, they are very easy questions. You can just use this information and find the answer. Now there are two specific cases here. See, if the time taken in each of these distances is same, if you are traveling with different speeds, there's distances. If the time taken is same, then what happens? If time taken is same, let me write here. If t1 equals t2 equals t3. So if the three time takens are same, the different time takens are same. So we are traveling a distance d1 with speed s1. We are taking some time, and we are taking same time to travel the further distance with a different speed, and we are taking same time to travel the remaining distance with some other speed. So in that case, if t1, t2, t3 are same, in that case the average speed becomes simple mean or simple average or arithmetic average of the three speed. It becomes s1 plus s2 plus s3 by 3. Basically, I should write it becomes the arithmetic mean of the three speeds, s1, s2, s3. There can be more speeds also. Right now, I've taken an example of three speeds. Fine, that is a specific case. Now, the second specific case is that if the distances to be traveled is same, that means if d1 equals d2 equals d3, in that case, the average speed becomes the harmonic mean of the three speeds, that is 3 upon 1 by S1, 1 by S2, 1 by S3, which is nothing but harmonic mean of S1, S2, S3. So these terms, arithmetic mean, harmonic mean, you may have studied if you have studied mathematics after 10th also. If not, then don't worry. This is our simple basic method, right? But these are two specific cases. That's why we are talking about them. Acha, before moving further, can you tell me if S1 equals S2 equals S3, then what will happen? What will be the average speed? Now, can you tell me? If S1 equals S2 equals to S3, if the three speeds are same, then what will be the average speed? Please comment first. Yes, it will remain same, S1, S2, S3. The speed will remain same because the speed is constant throughout already. So that constant speed is what we are calling average speed. So average speed remains same, S1 or S2 or S3, whatever you say. It is same thing. Okay? It's no mean, it's same now. So basic idea is that you must understand, you must know that what is the meaning of average speed. See, if you see these formulae here, so they look mathematical, right? Some of the comments I could see here, they look mathematical or something. Yes, they are mathematical, but they are not required. Most of the times they are not required. What is required is that understanding that what is the meaning of average speed. So average speed is the constant speed with which we can travel the same total distance in same total time which we are traveling otherwise with the different speeds. Fine. I hope this is the basic part which is clear about average speed. Now let's quickly solve a question. Here's one question. Please answer this. Okay, I can see one answer by Kopal here, 4.17. Please recheck. Vipul, it is asking about the round trip. What is the approximate time taken for the round trip? That means you need to use both the journeys, forward and backward. Damodar, Archie, what you have calculated, is that speed or time? Question is asking about the time, not speed. Yes, Manish, question says out of 300 kilometer, first 100 kilometer at a speed of 100 kilometer per hour, the next 100 kilometer at 200, and the last 100 kilometer at a speed of 400. All of you are missing the round journey part. Archie, we are to calculate the time, isn't it? So using that speed now, please calculate the time. $17.5, Usha. No. Okay, by the way, what do you mean by round trip? Yes, Aditya, Jitul, that's correct. Good. What do you mean by round trip? Okay, let's check it now. Please tell me in the comments, how should we approach it? Yes, Manish, that's correct. Going and coming back. So forward journey plus return journey. So forward time, onward time, and return time. That's true. So how to approach this question? Please tell me. How have you solved it? So it is mentioned here. Let me draw the diagram first. So out of total 300 kilometers. So first 100 kilometer and the forward journey has been traveled with a speed of 100 kilometer per hour. This we are talking about the forward journey, yeah, onward journey. So, and the next 100 kilometer has been traveled at a speed of 200 kilometer per hour. And the last 100 kilometer distance has been traveled at a speed of 400 kilometer per hour. So this is about the forward journey, and it says if it returns with the same average speed as it had during its onward flight. So the return speed is the average speed of the forward one. So what is that approximate time taken for the round trip? That means the forward time and the backward time. Both we have to calculate. So how to start this question? Do we need to calculate the average speed to calculate the return time? How to calculate average speed here? If there are ads in between, you can skip that. Don't worry. Okay, Abhay says taking speed average, then finding the time of one trip, then double the round trip. Okay. But is it required? Is it required? Now listen everyone very carefully. It's very simple thing. This question is a trap question. It is not calculative question. We are to find average speed? No, we are not to find average speed. See, can you tell me in this first 100 kilometer onward journey, this forward journey with the speed of 100 kilometer per hour, what is the time taken here? It's 1 hour, isn't it? 100 kilometers the distance, speed is 100 kilometer per hour, so it will take 1 hour. Yes or no? Good. Next. So next 100 kilometer distance is to be traveled with the speed of 200 kilometer per hour. How much time will it take? Exactly, Siddhanshu. That's perfectly nice. That is what is supposed to be done. So the time taken for this 100 kilometer with a speed of 200 kilometer per hour is 1/2 hours. Is it not? Simple, distance upon speed. And similarly, the time taken in this last 100 kilometer is again distance upon speed. That is 1/4 of the hour. So now the total time taken for the forward journey is 1 plus 1/2 plus 1/4 of the hour. Yes or no? Right. So yes, we can say it is 1.75 hours. Now, when we are coming back, so we are going to take same total time again, because we are to travel with the same average speed. And I discussed it in the last slide. What is the meaning of average speed? Average speed means that only, that we travel the same total distance in same total time. So whatever is the time taken in the forward journey, that should be the time taken in the return journey as well, right? So there is no need to calculate the average speed because only time is to be calculated, right? So time should be same as taken in the forward journey. So in the return journey also it is going to be 1 plus 1 by 2 plus 1 by 4 of the hours. The total time taken for the round trip is simply double of this, right? So 1 plus 1 by 2 is 1.5, 1.75 ka double. So twice of 1.75, that is 3.5 hours. Most of you already wrote that. Fine. So average speed was not required in this question. Okay. Okay, let's move further now. Now here's a special case of TSD, and lot of questions have been asked on this special case many times. If you will see the previous year's papers, while I was preparing non-engineering videos for our first and second batches are not I think reached there yet, but first batch has covered that. So while I was preparing the non-engineering videos, I found that almost every year or every alternate year, this special case was used in CAT and in ZAT as well. Okay, now let's see here. Petrus, calculating average speed is not required, was not required in the last question. We can calculate that, but it was not required. Yes, Devina, that was the point. You made an easy question tough. That's what I said. That was a trap question. So don't be trapped. So whatever is being asked, just be specifically focused on that and do it. Okay, let's come back here. Yes, root xy, Rashi is mentioning. Good. So see, what is the special case here? So it says, now leave the previous part. Please everyone focus here. It says A and B start walking from P to Q and Q to P respectively at the same time. So there are two persons, say A and B. Let me draw it. There are two persons, A and B. They are starting from P and Q. So this position is P, this position is Q. So they are starting at the same time towards the other end. Okay? So that is the situation here. You call it Radha concept. What is that? Anyway, let's see here. So A and B start walking from P to Q and Q to P respectively at same time. So A is starting from P and going towards Q, and B is starting from Q and coming towards P. Fine. So they start at the same time, and after T minutes they meet at point R. So they are starting together. So they are going to meet somewhere in between. Okay. So let's say they meet somewhere maybe here. So please tell me one thing. B has reached here and A also has reached here. So what will be same in their journey? The distance, the speed, or the time taken? Please tell me fast. What will be same? What will be the constant thing in their journey now when they are meeting somewhere in between? What is going to be the constant? Yes, time taken is constant, right? See, they are starting at same time and they are meeting here, they are crossing here at also the same time. The time taken is same. So if time taken is same, then distance and speed are going to be directly proportional, right? So who will travel the more distance? Whoever is having more speed, isn't it? Jiski speed zyada hai. Whoever is having more speed will travel more distance, like that. And if they are having equal speed, then they are going to meet in the exactly middle. Fine. Anyway, so now they have taken same time, that is T. So the speed of the person A was, let's assume it to be A only. So the distance traveled is A into T. Fine. So this distance traveled is A into T. I'm assuming the speed of the person A is A only. Similarly, this distance traveled by the person B will be B into T. Yes or no? Because speed of B is B now and he has taken time duration T. Fine. Next. Now, from this point was known as R. Now, from this point, they continue walking on their way. So, they continue. So, A was moving towards Q. So, A will continue towards Q and B will continue towards P. and they reach their destination in x and y minutes respectively. That means A is going to move further, A is going to take further x minutes. So speed of A was A, so in x minutes he is able to cover this much distance. That means so the speed into time, so they should be also be equal to A into x. And similarly, this distance is also going to be equal to, this is being covered by B in y minutes. So this is going to be equal to By. So basically, we can get the relation between x, y, A and B from here. So AT is equal to By, AT equals By, and this BT equals AX, isn't it? So if you simplify this, if you just multiply them, you can cancel out AB from both sides, isn't it? If we multiply, just multiply both the equations, so A into B into T square will be equal to A into B into XY. So because A into B is not equal to 0, that can be cancelled out. So from here we get to know that T equals root of XY, which few of you already mentioned that, isn't it? And the other case, if I divide both of them, if I divide both of these equations, now T will be cancelled. If I divide both of them, then I'm going to get A by B equals B by A into Y by X, which means A square by B square equals Y by X, or the ratio of the speeds of the two persons A and B will be square root of the Y by X. So these are two important results from here. By is not equal to Ax, Anusha. This By is the distance traveled by B in y minutes, isn't it? And the same distance was traveled by A initially in T minutes. So At equals to By. See, this At equals to By. And similarly, this Bt equals to Ax. And just by using these two equations, so far we have got these two results. And there is one more very important result here. There is one more very important result here. Highest technical falcon, that's the second result. S1 by S2 is same only, A by B. Now another result is that, now let's see very carefully. See very carefully what is happening actually. See, this A, can you think how much time A has taken to travel the whole distance? Can you please tell me how much time A has taken to travel the whole distance? How much time A has taken to travel the whole distance? पारस A square by B square is Y by X, तो A by B square root नहीं आएगा क्या? So A has taken T plus X minutes, isn't it? Yes, that's correct. So A has taken T plus X minutes total. And let me write here. So A has taken total T plus X minutes. And similarly, B has taken how much time? So B has taken total T plus Y minutes. So B can travel the same distance in T plus Y minutes alone. Fine. So A can travel the same distance in T plus X minutes, which can be covered by B alone in T plus Y minutes. But when they are moving together, they are able to travel that distance in T minutes, isn't it? So there's very important relation here, another relation here, that 1 upon T plus X plus 1 upon T plus Y equals 1 upon T. It's 1 upon T plus X plus 1 upon T plus Y equals to 1 upon T. So these three are very important relations from this special case, and as I said in the beginning, this special case has been used in CAT and ZAT and of course the other tests also very frequently, very frequently. So if you are familiar with these results, then you can solve the questions very fast. Otherwise, you need to go through all the steps again and again. Fine? Okay, how? Let me make it clear now. See, using a slight concept of relative speed here, when the speed of A we can say, which I mentioned as A only, the speed of A is the total distance upon time t plus x. Yes or no? A was the speed of A we had taken here, right? So A equals to distance upon t plus x, distance upon time. Fine. Similarly, B equals d upon t plus y. But when they both of them are moving together, they are traveling this distance in t unit of time. That means at that time the relative speed becomes A plus B. So A plus B is actually distance upon time t. So from this it is very clear, if you just substitute the value of A and B here, you will get this result, right? If you just substitute the values of A and B here, you will get this result, that 1 upon t plus x plus 1 upon t plus y equals 1 upon t. Is it okay? Shruti, here it is. So this is the last step here. So basically these are the important results, and most of the times this first one, which many of you immediately recall, this first one is used very fast, very frequently. Okay, so let's apply it in few questions now. Yes, this is a very important case, very important special case, certainly 3 marks pakka, maybe more than that. Maybe more than that. Okay, so let's solve question now. Now, only thing is that you need to identify, you should be able to recall what is given and what is being asked. Now, as I said in the beginning also, if you just remember the formula, you will be very easily puzzled. What is given, what is being asked, you can be puzzled. So you need to understand carefully what is given and what is being asked. Fine. So that's why I said earlier also, it is always beneficial to draw the situation clearly. So that we are able to visualize mentally. Fine. So when you are able to visualize the things, then it is easier to solve. Okay. Okay. Now the question. Here it is. Please answer this question fast. Rutu, you are having application class or not? That you need to check on your Facebook group. Now in this question, you have to find the distance between P and Q. Karan and Arjun start running from P and Q towards Q and P respectively. They meet each other after time t. Thereafter, Karan and Arjun take 16 and 25 seconds to reach their respective destinations. If Karan's speed was 12, find the distance between P and Q. Excellent. I have already got one answer by Vihana. There are a lot more concepts remaining, very important concepts, very interesting concepts are there. So please do it fast. Excellent. Kopal, Usha, Petrus, Chinmay, Shikha. Good. See, situation is same, right? Situation is same. Though in the earlier case we used the names A and B. Now it is Karan and Arjun. And after meeting wherever they are going to their Mataji or not. That's not our task here, Piyush. So T we do not know, but it is mentioned that thereafter Karan and Arjun takes 16 and 25 seconds. So aren't these values x and y only, right? So it is given x to be 16 seconds and y to be 25 seconds, isn't it? ठीक है ना? So Karan is the first person and Arjun is the second one, right? As we draw in the previous diagram. So Karan's speed is given to be 12 meter per second. The speed of Karan is 12 meter per second, and total time taken by both of them is t plus x and t plus y respectively. Fine. Now x and y are given. Can you calculate the value of t? Remember the result? So t equals to nothing but square root of x into y. So just plugging in these values, so 16 times 25, no need to multiply, 16 ka square root would be 4 and 25 ka square root would be 5. So this is 4 into 5, that is 20 seconds. So t comes out to be 20 seconds. So we need to calculate the distance between P and Q. So we can find out the time taken by current. So time taken by current, basically it is equal to t plus x, that is 20 plus 16, which is 36 seconds, right? And speed of current is given to be 12 meter per second. That's it. So the total distance which we are talking about between P and Q is simply speed into time. Speed of current into time taken by current. That is 12 into 36, which is 432 meters. That was direct application of the previous concept, isn't it? Okay, let's move further. Next question. Okay, not next question. Now we are moving on the next concept of relative motion. So what do we mean by relative speed? That's also a very important thing. Are you able to hear me? Shivansh? Is my sound audible or not? I hope it should be audible. Are you able to hear me? Please confirm. Yes, now? Okay. Fine. So there was one comment by one student. Sir, please speak. Anyway, okay, fine. Okay, now what is the meaning of relative motion or relative speed? So relative speed is an important concept. So whenever there are more than one moving objects, there are more than one runners, in that case it becomes difficult sometimes to get hold of the motion of all the moving objects. Fine. So in that case, this relative motion or relative speed plays an important role. So it's a very basic concept. It's a very basic thing. But if applied improperly, it can create havoc also. So let's understand. Let's try to understand and use it. Yes. So basically, relative speed. What is the meaning of relative speed? So if there are, let's say, two persons A and B, let's say they are running in same direction. If this diagram is clear, you can see that one is moving faster, one is moving slower. So let's say one is moving with a speed of 90 km per hour. I'm assuming that. And other is moving at a speed of 80 km per hour. They are starting at same point. They are starting from same point and in same direction also. They are moving in same direction. Fine. Abhay, in the previous question, T was the initial time of the meeting, isn't it? We did the special case, that was direct application. Okay, let's come back here. So if A is moving at a speed of 90 km per hour, B is moving at a speed of 80 km per hour. So before we get to know what is the relative speed and all, let's try to visualize it. Please tell me, I'm standing on road. I'm standing on road and there are two cars are moving. So one car is moving at a speed of 80 km per hour. It will appear to be moving very fast. Yes or no? Yes, of course. And then little while away, there is another car with a speed of 90 km per hour. And if that crosses me, then it will appear to be moving even more faster, right? Even faster than the earlier car. Fine, these are the two cars. So with respect to the person standing on the road, the two cars are moving faster. One was moving with the speed of 80 and other was moving with further higher speed, that is 90. But now, just think, so when that car traveling with the speed of 90 km per hour will overtake the car with 80 km per hour, right? When the car with the speed of 90 km per hour will overtake this earlier car traveling with the speed of 80 km per hour. So the person sitting in 80 km per hour, they are able to see that the other car is moving faster. But will they be seeing it same fastness as observed by the person on the road? Yes or no? Yes or no? I repeat again, please listen carefully. My question is, this 90 kilometer per hour car's speed when observed by an observer sitting in this car, will it be same observation as observed by the person standing on the road outside the two cars? Will it be same? Certainly not. So why there is this difference? This difference is because of the platform from where we are observing, right? It is a difference due to the platform from where we are observing. If you are observing from a stationary place, so we are seeing both of them are moving faster. But we were already moving with a speed of 80 km per hour. So in that case, we are seeing that person moving away from us with a slight speed, less speed, right? In comparison to the person standing outside both the cars. Fine. So that is the concept of relative motion. So whatever motion we are observing presently, it is relative to our motion. So basically, when I'm seeing other objects moving, I don't consider myself moving. So I consider myself to be stationary. Then I see this person is moving there, this person is moving there, this person is moving with that particular speed and so on. So now the person sitting in a car with a speed of 80 km per hour, they are seeing this other car moving faster, but they are not seeing this car moving with the speed of 90. They are not feeling that. So what is their feeling? So assuming them to be stationary, with what extra speed they are moving? They are moving with an extra speed of 10 km per hour, right? That is the difference of the two speeds. So that becomes the relative speed when the two objects are moving in same direction. So relative speed becomes 90 km per hour minus 80 km per hour, which is 10 km per hour. So basically, what is whose speed is this 10 km per hour? Whose speed is this 10 km per hour? So this 10 km per hour is not the speed of any of the person A or B. Then whose speed is this 10 km per hour? So this 10 km per hour is the speed at which the distance between the two objects or two cars is changing. I repeat, listen carefully and try to understand it carefully. This 10 km per hour is the speed at which the distance between the two cars is changing, increasing or decreasing, whatever be the scenario. ठीक है ना? So this is the speed at which the distance between the two objects is changing. So if they are starting at same point and they are moving in same direction, so in 1 hour B traveled 80 km, A traveled 90 km. So initially the distance between them was 0, and after 1 hour the distance between them has become 10 km, isn't it? So every hour the distance between them is increasing now at a speed of 10 km, at the rate of 10 km per hour. That is known as relative speed. Fine. So rate of change of distance between two objects. So that is known as relative motion or relative speed. So what is the speed at which the distance between two objects changes? That is known as relative speed. So it is not actually speed of any of the runners, but this is the speed at which the distance between them changes. So how do we apply it? So we apply it by making the slower one stationary. So preferably we make the slower one stationary. So if they're moving in same direction, the distance between them is increasing at the rate of their difference. So but if they had moving in the opposite direction, in that case, let's say this person A dash, it is moving in the opposite direction with a speed of 90 km per hour. What will happen? Now the distance between A dash and B will become 170 after 1 hour, right? So that will be the sum of the two speeds. So in this case, relative speed becomes 90 km per hour plus 80 km per hour. That is 170 km per hour. Fine. So why? Because now the distance between them every hour becomes sum of the two distances traveled by both of them. ठीक है ना? So that was the only point. You already knew this result ki when they are moving in same direction, then the difference le lo. When they are moving in opposite direction, at that time we add the speeds. So, but what does it mean if you understand that carefully, conceptually, logically? So then you will not do any mistake while applying the concept of relative speed. Otherwise, most of the students apply the concept of relative speed in a wrong manner, or they are unable to apply it. Fine. Now let's move to use it in certain questions. Here's the first one. Okay, please try to answer it fast. Yes, exactly, Sushant. So relative speed is the distance rate at which the distance between the two objects changes. That is the meaning of relative speed. Now try to use it here. Okay, Abhay, now we are going to increase the speed. 1024 or 1040? Hasib, please check. Yes, that's true. Excellent. So after 8 a.m., we can apply the relative speed concept. Fine. So answer is correct. Let's move quickly now. So A and B, the distance between A and B is 300. These are A and B. So James start from A at 7 a.m. So James start at 7 a.m. at a speed of 60 km per hour. 60 km per hour. Arnold starts from B towards A. So Arnold starts from here at 8 a.m. at a speed of 40 km per hour. So at what time will they cross each other? So yes, of course. So because the distance between them is now decreasing, at what speed? Both of them are helping. So both of them are moving in opposite direction. So the relative speed becomes 60 plus 40, 100 km per hour. But they are starting at different times. James is starting at 7 a.m. and Arnold is starting at 8. So as many of you have done. So first what we can do, let James travel for 1 hour, and after that we can apply the relative speed. That is one of the way. Or you can also do another thing. Let's take Arnold back in time. Let's take Arnold back in time. So Arnold को 1 घंटा पीछे ले जाते हैं. So let's Arnold could travel 40 km in 1 hour. So if I increase the distance by 40 km, if I increase the distance by 40 km and let Arnold start from this point. Arnold start from this point at 7 a.m. Right? So now the distance between the two becomes 340 km. And both of them are starting at 7 a.m. now, right? That can also be the approach. So now the the relative speed is 60 plus 40, that is 100. Now this 340 km distance is to be traveled with the relative speed of 60 plus 40, that is 100. After 7 a.m., right? After 7 a.m. So after 7 a.m., that much time would be required. So that is 3.4 hours, or basically 3 2 by 5 hours, or basically 3 hours and 24 minutes. So after 7 a.m., 3 and 24, if you will add, so that is certainly 10:24 a.m. So this is the right answer. Fine. Okay, let's move quickly now. Another question. Please answer fast. Good, Piyush. If anything is you are finding helpful, so I'm really obliged for that. Thank you. Nice. Now please answer this question. Okay, answer here. That's true, Ankit. At an unknown time, a thief broke away from a jail cell. Policemen noticed thief missing from the cell at 11:30 p.m. If thief had continuously been running in one direction at 60, the speed of thief is mentioned here, 60 km per hour. Policemen started at 11:30, that is mentioned, and policemen immediately started going after thief in same direction at speed of 80. Fine. And caught the thief at 3 a.m. So at what time did the thief break free? (11:30 minus 70 minutes, that is 10:20. Good. Okay. Many of the students have already answered, so let's do it. And I certainly agree with all the answers and all the methods mentioned in the comments. See, what is happening here? The policeman and thief, right? There are two persons. They are starting from same point, but thief started earlier, right? So thief at an unknown time he started, and that time we want to calculate. At what time did the thief break free? So we need to calculate that time only when this thief started, isn't it? So I don't know at what time did he start. Anyway, so but his speed is mentioned as 60 kilometer per hour. 60 kilometer per hour. See, if you don't use relative speed, use simple things, use simple equation also. We had used relative speed in the previous question. Now let's first avoid relative speed. So thief took certain time to reach the point where it is being caught by the policeman, isn't it? And policeman has traveled with a speed of 80 kilometer per hour, and policeman started at 11:30 p.m. and caught the thief at 3 a.m. Caught the thief at 3 a.m. So can you tell me the time taken by the policeman to catch the thief? For how much duration this policeman is moving? Can we calculate that time? So 11:30 to 3, that is 3.5 hours, right? So the policeman is traveling for 3.5 hours. Is it not? Right? See, policeman is also traveling the same distance. The thief is also traveling the same distance. So if we use a proportionality which we discussed in the beginning of the session, both are traveling equal distance, right? So whatever is their speed ratio, the ratio of time taken would be different than that, isn't it? The ratio of time taken would be inverse of that. है ना? So the speed ratio is 80:60. Let me write here, the speed of police to the speed of thief, that ratio is 80/60, which is 4/3. That is the ratio of the speeds. So the ratio of time taken by the police and the thief would be inverse of this. So time taken by police to time taken by thief would be simply inverse of this, that is 3/4. Now we know that time taken by the policeman is 3.5 hours. Isn't it? So now can you calculate the time taken by thief from here? Certainly yes. Isn't it? So just simplify this. So 3.5 into 4, that will give you how much? 14. So 14/3. So time taken by thief comes out to be 14/3 hours. That means 3 4s are 12. So 4 hours and 2/3 means 40 minutes. So 4 hours 40 minutes is the duration for which this thief has been running, right? So now I have not used that relative speed scenario. I have simply used the proportionality because distance to be traveled is same. That's it. We are done now. So from 3 a.m. just reverse the time for 4 hours 40 minutes. If I go 4 hours back, I will be at 11, right? And I need to go 40 minutes further back, so that will be 10:20. So 10:20 is the starting time of the thief. Is it okay? And you could have used the scenario of relative speed as well. That will make the things much faster than this. So basic point is that there are various ways. There can be various ways to answer the same question. There can be various ways. So by using relative speed scenario, what we need to do? So for relative speed scenario, we just need to see that the policeman is traveling with an extra speed of 20 km per hour, isn't it? So with that extra speed of 20 km per hour, still it is taking 3.5 hours to catch, to cover that distance, to cover the extra distance traveled by thief, isn't it? So what is the extra distance traveled by thief? That is simply 20, the extra speed, 80 minus 60, that is relative speed, 20 into 3.5. So this 70 kilometer is the extra distance or distance created by the thief when he started earlier, right? So how much time did this thief took to travel 70 kilometer? We just need to divide this distance by the speed 60. So 70/60, that is the time when only thief was traveling, right? When only thief started traveling before this 11:30. So T will be 70/60, or basically 1 and 1/6 hours, which means 1 hour 10 minutes. So you just need to go back from 11:30, 1 hour and 10 minutes. If I go 1 hour back, that will be 10:30, and 10 minutes further, that will reach to 10:20. So इसमें से minus करना है हमें 1 hour and 10 minutes. Fine. So we could have used relative speed scenario. We could have used this a constant distance scenario, proportionality. So there could be various ways to answer the question. Fine. Or you can make simple equations also. That is also a way. Yes, Tarun, that's true. May 3 a.m. say, from 3 a.m. I need to subtract this time, 4 or 40 minutes, because that is the total duration of traveling for the thief till it is getting caught. So from 3 a.m. I can subtract this 4:40 to get to my answer, or I can subtract this 1 hour 10 minutes from this 11:30 p.m. Prakhar is asking, sir, could you explain how 3.5 hour has come? Are Baba Prakhar, the policeman started running at 11:30 p.m. and he caught the thief at 3 a.m. and we are assuming the policeman is running throughout, or whatever vehicle is being used, whatever is there. So he is running throughout. So from 11:30 p.m. to 3 a.m. what is the time? It is 3.5 hours. Is it not? So that's why I said we need to see the statements very carefully. Whatever information is provided there, that should be in our mind very carefully, very clearly. And for that purpose, it is better to draw the situation. And that's why I mentioned here, policeman with a speed of 80 km/h started at 11:30 p.m. and caught the thief at 3 a.m. I mentioned all the things here. Fine. And similarly, for the thief, I know the speed. I do not know when he started. That's what it will be found. But he was caught at 3 a.m. Okay, let's move further now. Let's quickly move further. There's one more question. Let's do it fast. Let's do it fast. Okay, so you are not having those, some students who are asking about whether application class is there or not. So we are going to extend this session so that we can end time speed distance. Fine? Are you ready for that? Still our few concepts are remaining, our linear races and circular races and meeting points, and some questions, some other questions as well. So are you ready for that? We can extend this session. So we are not limiting it to 9. We'll proceed further. Is it fine with everyone? Good. This session will be it will remain there on your this YouTube. Later also, if you are unable to continue or you want a break in between, it will be here only. So, but we shall complete the topic. Arey Baba, dinner you can take in between. I cannot. I need to wait for the end of the session. Yes, we will extend it by, I think, 15-20 minutes or maximum 30 minutes, I guess. Okay, please solve this question. Those who are able to continue, it's good. If you want a break in between, you can take a break and come back fast. This is a live class, Ridhima. I cannot stop the class in between, but you can take a break in between if you wish. That's not a problem. Okay, please answer this question fast and let's see so that we can finish it as soon as possible. Okay, I got one answer by Vihana, 1125. I will wait for 1 more minute for more answers. Hi, yes, Ishan, this is your first class of this last batch. This is basically this is pre-class. This is pre-classes. So in a way, it is just overview of the whole topic. This topic we covered in the first batch in, I think, 4 or 5 classes. Paras, what is your question? I am unable to see. TSD दोबारा नहीं होगा live class में practice के लिए. The live classes are there already. You can see the recording. Paras, you can always see the recording of the live classes. If you are from any of the earlier batches, so it is already done there. You can see the recordings anytime. And for this session also, recording will also be there. You can always see that. But attending it live means attending live, and seeing a recording is something different. Okay, answers here. See, it says a bird sitting on top of a wall spots an approaching train which is 900 km away from the wall. So let's say this is the wall. ऐसा मान लेते हैं, this is the wall, and the bird is sitting here, and the train is approaching. So let's say this is the position of the train here, and this distance is given 900 kilometers. Fine. So it is 900 kilometers away, and the train is approaching at a speed of 20 meter per second. The speed of the train is 20 meter per second. So the bird starts flying towards the train, reaches the train, and immediately flies back to the wall and again back to the train, and it continues like this till the train reaches the wall. So train is continuously coming towards the wall, and this bird starts moving towards the train and comes back and again moves towards the train and come back, and so on until the train reaches the wall. So that means certainly the path traversed by this bird would be of something this format. It will be going somewhere here, then coming back, then again moving further, because train has further moved some distance, so the bird would be traveling lesser distance than last time, and again coming back to the wall, and like this and this, something like this, isn't it? Till the moment the train reaches the wall. Finally, this is the situation. Is it okay? That's correct, Shriram. Ankit, good. Yes, Anshita, that is correct. So answer is right. So this is a situation, and we can very easily observe here that the distance traveled by the bird in the forward direction, that is towards the train, and then the distance traveled by that bird while coming toward the wall is always same in all cases, right? So whatever distance it is moving towards the train, it needs to come back to reach to the wall. Again, it is moving towards the train. Whatever distance it is traveling, then again it is traveling back the same distance, and so on. Fine. So question is asking, what is the distance covered by the bird while flying towards the train? That means if I get to know the total distance traveled by the bird, I simply need to make half of it, right? I simply need to make half of it, because the distance traveled by the bird towards the train and while moving away from the train is same for each of its flight, right? Because whatever distance it is traveling toward the train, it is coming back the same distance. Again, it is moving for some distance towards the train and again coming back, and so on. So how much distances are being traveled, that depends upon the moment of this train also. But whatever it is same in all the cases. So that's why I'm saying, if I get to know the total distance traveled by bird, then I simply need to divide it by 2 to find this answer. Now it is mentioned the bird flies at a constant speed of 50 meter per second. Now how to calculate this, that how much distance bird has traveled? How to calculate that? It's not difficult. Can you tell me how much time this train is going to take to reach to the wall? How much time this train is going to take to reach to the wall? How to calculate that? How to calculate the time taken by the train to reach to the wall? Fast, please. 12.5 hours. How did we calculate that? Distance upon speed. Speed of train is 20 meter per second. This is 900 kilometers. We need to convert it in meter per second. This is already in meter per second. We need to convert it into kilometer per hour. So 20 meter per second in kilometer per hour, how much it will be? Remember, 5 meter per second was 18 kilometer per hour. This is going to be 72 kilometer per hour. Right, this is 72 kilometer per hour. So by dividing, we can get the time taken, and that is the time for which the bird is traveling. It comes out to be 12.5, that's true, so 12.5 hours. So that is the time for which the bird is also traveling, and the speed of the bird is 50 meter per second. Can we avoid this much calculation? Can we avoid this much calculation? Because now I need to multiply the time with the speed of the bird and then dividing by 2. Can we avoid this much calculation? Yes, we can avoid. Yes, we can avoid. Now listen very carefully. Listen very carefully. We know that both train and bird are traveling for same duration of time. Yes or no? Yes. Both of them are traveling for same duration of time from this moment, right? Now train is traveling how much distance? 900 kilometer. How much distance bird will travel in the same duration? It depends upon their speed ratio. So what is the ratio of the speeds? It was 20 meter per second and this was 50 meter per second. So the speed ratio is 2:5, isn't it? So the bird is traveling with the speed 2.5 times that of the train. So in the same time, the train will travel distance how much? 2.5 times that of the train. So bird will travel 2.5 times that of the train. So train ka distance kitna hai? It is 900. So the distance traveled by the bird would be 900 into 2.5, right? And we just need to divide it by 2 to get our answer. Is it not? So 900 into 2.5 is, that is 2250, and dividing by 2 will give you 1125 kilometers. So this is the required answer, which most of you have already got that. Is it fine? Okay, let's move quickly to the next part now. Now gradually we are moving towards the little trickier part. Now this is meetings on a linear track. Now these are only two concepts remaining now. Meetings on a linear track, which includes your races as well, and then also meeting on a circular track. Okay, Dhananjay Modi ji asking why divided by 2. Let me get back to the question. Dhananjay, remember we talked about the journey traveled by this bird. So bird is moving toward the train, moving back to the wall. Again moving toward the train, moving back to the wall, and so on. Question is asking the distance traveled by the bird, distance covered by the bird while flying towards the train. It is not asking the total distance traveled by the bird. It is asking the distance covered by the bird while flying towards the train. So we are just seen in this diagram that distance toward the train and back towards the wall is equal. So that's why we need to divide it by 2. We need to divide the total distance traveled by 2 to get to our answer. Is it okay? Is it fine? Okay, let's move quickly now. I do not wish to waste any moment. So meetings on a linear track, that's again a special case, and a lot of questions have been asked in CAT repeatedly from this concept as well. Now there are two particular situations. What are the situations? The two runners, now this is a linear track. Now the two runners, let's say A and B, they start from opposite ends and move towards the other ends, and they continue move on this track in this to and fro motion. Fine, this is one scenario. So they start at same time and they move towards each other and they continue to the other end, then reach there and then come back and so on. So at how many different points are they going to meet? Fine. So this is the first scenario. The second scenario is that the two runners start from same end point with, of course, some different speeds, and move to the other end and then again come back and then continue this to and from motion on this track. So again, same question, at how many different points are they going to meet? Fine. So these are the basically point, at how many different points they are going to meet, at a particular meeting point where it is going to happen, at which point or at what distance from one of the ends, like that. So if this end is known as P, this end is known as Q, here also this end is known as P, this end is known as Q, and we will assume the speeds of A and B to be A and B only, and this distance is D. Find that the distance between the two endpoints, or the track length basically, is D units. So the basic concept here which we need to understand is that we are talking about the meetings. So let's talk about this first case here. So when they are coming toward each other, so they are certainly going to meet somewhere. They are certainly going to meet somewhere, yes or no? Of course, yes. So wherever they will meet, so they will certainly travel certain distances. Both of them will travel certain distances. Let's say they meet after some time t, as we did earlier also in a special case. So A into t is the distance traveled, this is B into t is the distance traveled, where A and B are the speeds, isn't it? So what is the total time taken for this first meeting? Can you tell me? For the first meeting, what is the total time taken? For this first meeting, what is the total time taken? Please tell me the answer. In the previous question, Amit and some of you asking why 2.5. Are Baba, speed ratio. Amit, the car house, and Shikha, it is speed ratio. 20:50 was the speed ratio, no? That is 2:5, or basically 2.5 times. That's how I did it. 5/2. Okay, anyway, coming back here. So for this first meeting point, the total time taken is t minutes, whatever minutes or whatever unit is there. Fine, that is t. Okay, can you also tell me what is the total distance traveled by the two runners? Total distance, I am asking. Total distance. Total distance traveled by the two runners in this duration. Individually, they have traveled AT and BT. So total becomes D, isn't it? The total distance traveled becomes D. Is it fine? Good. So that is the first meeting point, which is very obvious. Now let's move to the second meeting point. What happens when they are going to meet for the second time? This was the first meeting point. Let me mention this is first. Now what about second? So let me change the color. I'm using this green color now. So the second meeting, what happens? The person A who had reached here, now it will continue to the end and it will come back. I'm assuming the scenario here. So this A reaches B and then come back, and this person A reaches the other end Q and comes back, and this person B also who has reached here till the first meeting point, it also continues towards the P, reach there and move back, and they meet somewhere here. This is the second meeting point. Let's assume that. Okay, this is the second meeting point. Okay. Now just tell me that after first meeting point, how much more distance has been traveled? Yes, that's true, Piyush. The total distance being traveled now is 3D. See, after this first meeting point, A has traveled this remaining distance and came back till here. And similarly, B also has reached to this end point and come back again. So if you just see this green length, it is D plus D, 2D. So 2D extra distance has been traveled, right? After first meeting point, 2D extra distance has been traveled. That means total distance being traveled is 3D, right? That is D plus 2D basically. The total distance being traveled is D plus 2D, that is 3D till the second meeting point. Now, can you estimate कि second meeting point तक total time कितना लगा होगा. In the first case, we assume that time was t. So what is the time taken for the second meeting? What is the time taken of the second meeting? Is it also 3t? जैसा पहले t time लगा था तो is it 3t now? Yes. अरे बाबा, when d distance travel करने में time taken was t, so 3d distance travel करने में time taken is also 3t. That means individually everyone has taken 3 times of the earlier time, isn't it? So whatever distance was traveled by A earlier for the first meeting, now for the second meeting, a total distance traveled by A is 3 times of the earlier distance. Right? And this thing will continue. So every time after every 2D total distance, they will be meeting for the next time. So third meeting will occur when the total distance traveled becomes 5D. And time taken will also become 5t. So we also know at what timings are they going to meet and what is the total distances traveled by them. Distances are being traveled by them in their respective speeds ratio only. Fine, because they are traveling for equal amount of time every time. Fine. So that is a very basic thing. See, now we are skipping one thing here. I'm skipping one thing here. It is also possible that they are meeting while moving in same direction. That is also possible, na? That is also possible. So, but we are skipping that part because in our CAT part, in our CAT questions, that overtaking scenario is not there. So, whatever meeting we are discussing, these meetings we are discussing, these meetings are only those meetings when the two runners are approaching toward each other from opposite directions. Okay? Please understand it again. Anvita, how we got 3D? See, after this first meeting point, the distances traveled by both of the runners A and B, I have drawn in this green color. So just see and tell me how much is this total green length which I have drawn here. You can easily see it is the D plus D, that is 2D. Isn't it? So 2D extra distance has been traveled after first meeting. So total distance traveled till second meeting is 3D, that is D plus 2D. That makes it 3D. So every time this increase in distance would be 2D. So D plus 2D, that is 3D, then 3D plus 2D, that is 5D, and so on. So every time the total distance traveled becomes 2D, the two runners meet again. Fine? Yes, we are adding the distances traveled by both the runners. So, but that's what I'm saying. Individually also they are traveling the distance in the same ratio. So initially they took time t. So then for the second meeting, the time taken is 3t. For the next meeting, the time taken is 5t, and so on. Okay, na? Okay, in this, before I move further, let me ask you one question. Say A and B is starting here, and it is given that they first meet at a point which is 40 meter away from P. Okay, that is first meeting point. And let's say the second meeting point is maybe, what should I say? 10 meter, like 10 meter. The second meeting point is 10 meter away from the other end point. Can you tell me the track length? Please answer this fast. Please answer this fast, everyone. This first meeting point is 10 meter away from the initial point. This is point P. And the second meeting point is 10 meter away from the other end point Q. So please tell me this track length. Basically, tell me the value of D. Can you answer it fast? Wait, Ankit, let us finish this. This is our last. We are just one more topic after this. There is circular tracks, circular meetings. So after linear meetings, and then we will talk about circular meetings. So first answer this question. Yes, I'm waiting for your answer. See, the important thing here is, just as I mentioned earlier, so whatever distance has been traveled till first meeting, that is traveled in the time t, isn't it? And till second meeting, the distance traveled is in time 3t. So in 3t, the distance traveled by each of them would be 3 times of their first meeting point distance, isn't it? So A has traveled 40 meter till first meeting. So till third meeting, how much distance it is going to travel? So it is simply 3 times of that. That means 40 times 3, which is 120. But we know that this A has traveled how much? This is D plus 10, isn't it? So this 120, let me write here, this 120 is nothing but D plus 10, which gives you the value of D as 110 meters. So that is this track length here. Yes, this is 110, that is correct. So I'm repeating the question, Ridhima. Question was that first meeting point is 40 meter away from P, and the second meeting point is 10 meter away from Q. So what is the distance between the two endpoints, or basically what is the value of D? That was the question. So that we deduce how? We deduce that A has traveled 40 meter distance for the first meeting. Now for the second meeting, the total distance is becoming 3 times. So individually also they are traveling three times the distance. That means the A is traveling total 3 times of this, that is 120 meter distance till the second meeting point. And now for second meeting point, what is happening? So A is reaching towards Q, that is the distance D plus 10 meter. So this D plus 10 meter is 120, that gives you the value of D as 110. So that is the basic things about this meeting points and all. So if you understand this basic part, then it becomes very easy. Otherwise, it can become very complicated also. Okay? Distance traveled by each of them are different, Shruti, but the ratio would remain same, na? If total distance traveled is becoming 3 times, it means the individual distances travels are also becoming 3 times. It is not possible. So now think, is it possible that A has traveled 5 times the distance, but B has traveled the same distance only? No. If A has traveled AT, B has traveled BT in T time, so in 3T time, what is going to happen? A is going to travel 3T times A, and B is going to travel 3T times B, isn't it? So the individual distances traveled are also going to become thrice of the initial distance. Fine. That's why I had done this 40 times 3, that is 120. That's how we got this 120. Is it okay? Good. Okay. Now that was the basic part here. That first meeting happens when the sum of the distances traveled was becoming D, and the next further meetings happen after every 2D distance. Now, what happens in this scenario when they are starting from the same endpoint? So if they are starting from the same endpoint, in that case, this first one-way journey remains blank, right? So when will their first meeting happen? What will be the sum of the distances traveled? So A will reach to the end and then come back, and B, who is slower, we are assuming that B is slower, so B will travel that much distance, and that will be the first meeting point. So till first meeting point, sum of the distances traveled becomes how much? It becomes 2D in this case. And now further situation is exactly same as earlier. The second meeting point will happen when the sum of the distances traveled becomes 4D, then 6D, and so on. Fine. The further things are exactly same as we did in that case also. So, but for the first meeting point, this first one-way journey of this faster runner is without any meeting, and after that they are again going to meet every time. Is it okay? Okay. Yes, these questions have been asked in CAT repeatedly. I said that, Ridhima. So that's why I said this is also an important topic. And in CAT doesn't use the overtaking situation. That's why we have avoided that. We are not talking of the overtaking meetings. We are only talking about the meetings when the runners are coming from opposite directions. Let's solve 1 or 2 questions quickly. So here it is. 2 friends start from the opposite ends A and B of a linear track and keep running between the ends for the infinite time. Let's solve it together. Let's solve it together. So they meet for the first time at a point. They meet for the first time at a point 60 meter from A. Okay, so let me draw the diagram. Let me draw the diagram A and B. So these are the 2 endpoints, opposite ends A and B. So they meet for the first time at a point 60 meter from A. So the first meeting point is somewhere here. This is 60. Total track length is 100 given. Total track length is 100 given already. So first meeting point happens here. This is 60 meter. This is first meeting point. Total track length is AB is 100 meter, that is given. So question is then, how far do they meet for the fourth time? How far do they meet for the fourth time? Can you answer this question fast, please? This is the first meeting point. So question is, how far from point A do they meet for the fourth time? Till fourth time, can you tell me what will be the distance traveled? For the first meeting, it was D, then total distance 3D, then 5D, then 7D, isn't it? The total distance is going to be 700. But individually also it is going to become in the same ratios. So that means this first person, whatever person is here, who is starting from this end, so he traveled 60 meters for the first meeting, right? So for the fourth meeting, he is going to travel 7 times 60, isn't it? So the distance traveled by this first person here is going to be 7 times 60, that is 420 meters. So we just need to count starting from here. If 420 meter, after traveling 420 meter, what will be the position where this first person would reach? So 100, 200, 300, 400, and then 20. So 20 meter from A. That's it. Is asking from how far from point A. ठीक है ना? Yes, 20 is the correct answer. So answer would be 20 meter from A. So this question becomes very simple if we understand the basics of the question. Then it's very simple, just directly the answer. Yes, 20 is correct. It is 20 meter from A. So how I got to know 20? Because I know that the total distances are becoming D, 3D, 5D, 7D and so on. But the individual distances are also being traveled in the same ratio, in the same multiplication as we checked in the previous question. So if this first person who is starting from here, the first friend, so he has traveled only 60 meters for the first meeting. That means for the fourth meeting, he is going to travel 7 times of this, that is 420 meters. So I just need to figure out this location. So that is 100, 200, 300, 400 and 20. So 420 meter, that means 20 meter away from A. That is our answer. ठीक है ना? Last concept, time not mentioned. Time was in the same ratio, bhai. That was we discussed. That's how we got to know. For the first meeting, they are meeting at time t. For the second meeting, they are meeting at 3t, like that. अच्छा उस वाले दूसरे वाले में बोल रहे हो उसमें भी same way, same, it will be same thing in the same ratio. Time will be in the same ratio. Okay, let's take one more question. Again, it's a similar question. Please answer. Please answer fast. It's again a similar question. Please answer fast. But now mind that now two persons, Sid and Kid, speeds 30, 20 respectively start from same end. Now they are starting from same end. That's the difference now. Okay, you are asking about the timing in this concept, na? When they are traveling from same end. So if they are starting from same end, as in this case, this is end A and end B. The two persons, Sid and Kid, they start from the same end point A with speed 30 and 20. So that means Sid is faster. So and keep running to and fro. They meet for the first time at a point 20 meter from B. They meet at a point 20 meter from B. That means Sid, who is faster, reaches B and comes back. and he comes back 20 meters. That means he travels total 120, and while in the same time this kid is able to travel only this 80 meters. By the way, 30-20 ratio was given, that could have told the answer. Otherwise, this was not required. If 20 is given, that was sufficient. So this data is redundant, it's not required. Anyway, so this is the first meeting point. This is the first meeting point. Now, whatever time they have taken for this first meeting point, for second meeting point, they are going to take same more time, because so far they have traveled total 2D distance, and for the next meeting point, they are going to travel together 2D more distance every time. So time taken would be same now, right? In this case, time taken would be same. It is not going to be 7 times or like that. So it will be same now. So that means for this first meeting, this kid has traveled 80 meters. For second meeting, this kid will travel 80 more meters, right? Like that. So for third meeting, how much distance would be traveled by this kid? That is 3 times of 80, that is 240 meters. For fourth meeting, for 4 times of this 80, that is 320 meters. Now we just need to find their locations, find out their third and fourth meeting points. 240 meter ka matlab 100, 240. So 40 meter from A. 40 from A. Right? And 320. So 100, 200, 320. So 20 meter from B. That's it. Is it okay? Have you got this point? That when they are meeting for the first time, the total distance traveled was 2D. We wrote that earlier. For the first meeting, the total distance traveled was 2D. And for second meeting, the total distance traveled would be 4D. For third meeting, the total distance traveled would be 6D, and so on. Every time 2D distance would be added. So this time the time taken are equal, right? Time is not becoming D, the T, 3T, 5T. No. The time is same basically, whatever it is. If you call 2T, then you will call it 4T, and so on. Equal time is being taken. That means every person is traveling equal distance in the same part. So in the ratio 1:2:3 only. So for the third meeting, the distance traveled would be 3 times of the distance traveled in the first meeting. For the fourth meeting, distance traveled would be the 4 times that was the distance traveled in the first meeting. So in the first meeting, this kid traveled 80 meters. So for the third meeting, this person kid will travel 3 times distance, that is 240. And for the fourth meeting, it will travel 4 times of this, that is 320. And that's how we got our locations. Is it okay? Yes, we can use this concept you said also. It is smaller than 120. That's why I use it. Otherwise, let's check that. 120 into 3, that would be 360. Isn't it? If I'm using the same thing for SID, so for the third meeting, SID is traveling 120 into 3, that is 360. So 360 kahan pahunchega? 100, 200, 300, and then 60. That means 40 from A. Same thing, right? And similarly for the fourth meeting, 120 into 4, that is 480. Right? So 480 kahan pe jayega? So 100, 200, 300, 400, and then 80. That means 20 meters from B. Is it okay? Good. So I hope it is clear. Is it okay, Abhay? And Rutu, Ridhima? I hope this should be fine. Now let's proceed further fast. We should head to the last of our concept now. Is it fine? Okay. So here's one question from the topic of races. First do that also, and then we shall move to the circular track. Yes, please first do this question also. Then we shall move to the circular meeting, which is the last part now. Abhay is asking, how did we calculate SID distance 120 meter? As we got the distance of kid to be 80 meter. Abhay, that was mentioned there, na? It was mentioned there that they meet 20 meter from B. Abhay, it was mentioned, Abhay was that SID was moving faster. So SID will travel the distance complete and then travel 20 meter more. And then they meet for the first time. Isn't it? It's not possible. The Sid was moving faster and Kid was moving slower. So when they will meet? So of course Sid has traveled 100 meter completely and then turning back. Only then they can meet. ठीक है ना? Ashani, why did we take the time constant? Ashani, we have been discussing this since beginning. We did many questions like that. We are starting at same time and we are meeting at same time. That means time is same. Time taken is same. Ashani, that is same thing. 2D, 4D. If you say 2D, 4D, 6D, that is same thing. You can cancel out two common part. So 1, 2, 3 and same thing. There is no difference. Okay, answer this question now quickly so that we can move to the last part, that circular meeting. And Ujjana, what is this, if I'm pronouncing it correctly? So TSD is time, speed and distance. This is an important topic of arithmetic related to time, speed and distance when the runners are moving and we need to calculate the distance traveled or speed or time taken and on. Okay, please answer this question quickly. Yes, that's correct answer. Shikha, good. 880 is correct. Nice, Harsh. Okay, let's see here. Again, this can be taken as a calculative question or it is very easy question if you understand the basics. So that's what our purpose is right now. We should be clear about our basics. So it says in a race of 3 horses, the first beats the second by 11 meters. So there are 3 runners, there are 3 horses, first, second and third, right? This first, second and the third. There are 3 horses, right? So the first beats second by 11 meters. That means when the first horse reaches the end point, the second horse is behind him by 11 meters. This distance between them is 11 meters. Yes or no? The total track length is D. So when the first horse has traveled D distance and the second has traveled D minus 11 meter. We can say that, right? And further it says, and it beats third by 90 meters. So in this duration only when A has finished the end point. So the third horse is 90 meter away. That is the situation mentioned in this first sentence. In the second sentence, it says if the second beats the third by 80 meters, that means in the same race, when second finishes, when it says second beat the third, it means second has reached the finish point. So when second has reached the finish point, now third is lagging by 80 meters. So the third runner, the third horse is 80 meter behind him. Is it fine so far? I have just drawn the diagram for all the given things. So what was the length in meters of the race course? So that's what we need to find out. Okay, many of you have already found the answer. That's a good thing. Karthik, I have already answered that. If you multiply by 6, then you need to multiply the earlier case with 4 and 2. That's same thing. Not with multiply with 6. Because see the ratio of the timings. That was 2D, 4D, 6D, na? 2D, 4D and 6D. So if you are taking earlier time to be 2D, then the next time would be 4D and 6D. So 2D को 6D बनाने के लिए आपको 3 से ही multiply करना होगा ना कार्तिक, not with 6. Okay, let's come back to here. So now in this case, if I see distance between 2 and 3 here, it is 79 meters. Yes or no? But when this 2 travels further 11 meter, the distance between them becomes 80 meter. So this 1 meter increment is coming out to be there when this 2 travels 11 meters. That means, can I say in that duration when 2 travels 11 meter distance, the horse 3 travels 1 meter less than that, that is only 10 meters. Yes or no? Is it okay? Are you able to understand this part? I'm not making any equations, I'm not using any variables. I'm just using the whole situations given. Is it okay? So in that duration, when this horse 2 travels this 11 meter distance, so this horse 3 doesn't travel 11 meter, because agar horse 3 is also moving 11 meter, so the distance between them would have remained same 79 meters, but it is becoming 80. It is increasing by 1 meter. That means horse 3 is running 1 meter less than that. That means horse 3 is running only 10 meters. Is it fine? Right? Good. Now we are almost done. See, so in a race of 11 meters, I can say the second beats the third by 1 meter. But in this actual race, we know the second beat the third by 80 meters. Right? Here we can see if the race length or track length would have been only 11 meter, then the second horse would have beaten the third one by 1 meter only. But we know that the third was beaten by 80 meters. So what we need to do? We just need to multiply this whole scenario by 80. So that this the third horse is being beaten by 80 meters. That means the track length would be into 80, which is 880 meters. So when the second horse has traveled 880 meters, in that same duration, this third horse is going to travel only 800 meters and is being beaten by 80 meters. Fine. So that's how this is the answer. So nothing to be written, nothing to write. We just need to understand the situation, and it is very clear if we make the diagram properly. Is it okay? Good, good. Now let's move to the last part for the today's session, that is meetings on a circular track and its properties. So meeting on a circular track. So what do we mean by that? So meeting on a circular track, it is exactly similar to in the linear track. The only difference, there is a slight difference only. So what is the difference? So there are two situations again. So this is a circular track. The two runners could be moving in the same direction. The two runners could be moving in the same direction, A and B, or they could be move in the opposite direction. Okay? Now, if they are moving in same direction, I am assuming the speed of A is more than that of B, that I am assuming. Okay? So, if A is moving faster than B, when they are going to meet for the first time, when it is going to happen? Of course, B is moving slower, so B would be traveling less distance, maybe that much distance traveled by B. B has traveled maybe X distance, and A would travel this one extra round than that. Is it not? So A would travel one complete round plus X distance. So one complete round plus X distance. So then they are meeting for the first time. So basically, whenever they are going to meet for the first time, this is the first meeting now, we are assuming that. So whenever they are meeting for the first time, the faster runner travels one extra round than the slower one. And every time whenever that happens, that the faster runner has traveled one extra round than the slower one, they would be meeting. Again, one more extra round, one more meeting, and so on. Fine. So at a particular moment, if we get to know that whatever, what is the number of rounds, what is the number of complete rounds taken by the two runners, we could calculate the number of meetings happened till that point. Fine. So that is a basic thing. So while they are moving in the same direction, in that case, the difference between the number of rounds completed, that will give us the number of meeting points. And while moving in opposite direction, so whenever they meet, so B is the slower one, so B has traveled this much distance. A is the faster one, so A has traveled this much distance. So whenever they are meeting while moving in opposite direction, so some of the distances traveled is becoming one complete round. So for the first meeting, the total distance becomes 1 complete round. Here, the difference of the distance was becoming 1 complete round. ठीक है ना? हाँ, that is relative speed scenario, Piyush. That is fine. So that can be used for smaller situations, but that becomes the easier thing if you understand that way, that the faster one has to travel 1 extra round. So by using relative speed scenario, we can make the slower one stationary and we can make travel only the faster one. Faster one will be traveling with the relative speed. That's fine. That's correct. So but now, right now I'm making both of them move. So what is happening is that when they're moving in same direction, so whatever is the difference between their number of rounds traveled, that will tell me the number of meetings. And while they're moving in opposite direction, so whenever they meet, so sum of the distances becomes 1 complete round. So at a particular moment, whatever is the total distance traveled by both of them together, so number of completed rounds, that will tell me the number of meetings. ठीक है ना? Now, how much distances are they going to travel? That depends upon their speed ratio. That depends upon their speed ratio. Let's say speed of A is 30 meter per second and speed of B is 20 meter per second. ठीक है? So at a particular moment, what is going to happen? Their speed ratio is 3:2 basically, right? Their speed ratio is 3:2. So when the slower one would travel 2 rounds, the faster one A would travel 3 rounds, and then the difference is going to become 1 round. So when A has traveled 3 rounds, then they are going to meet for the first time. And where they are going to meet? So this difference between them was becoming 1 round when A has traveled 3 rounds. That means A has traveled its starting position again, and B has also traveled the starting position again. So every time they are meeting at the starting point only. There is no other point where they can meet. Is it okay? That is the only point where they are meeting. Before that, they are not meeting anywhere. So like this. And while they are moving in opposite direction, in that case, same speeds were 30 meter per second, 20 meter per second. I'm assuming that. So this is 30 meter per second, 20 meter per second. So whenever they are meeting for the first time, the sum of the distances traveled becomes 1 complete round. So when A has traveled 3 rounds completely, so B has taken 2 rounds completely. Fine, and both of them have reached the starting position again. So till that point that they are reaching for the starting position again, so till that point, whatever meetings have happened, they have happened at equal distance, at equidistant points. So the ratio is 3:2. So A has taken 3 rounds and reached starting position, and B has taken 2 rounds and reached starting position. So total rounds traveled by both of them together is 3 plus 2, 5. That means both of them, when reached to the starting position again for the first time, so they have met by that time total 5 times. And while reaching here, that was the 5th meeting. That was the 5th meeting. And where are the other 4 meetings? In between this track. So basically all the 5 different meetings would be equidistant, where this is the 5th meeting point. This is the 5th meeting point, and others would be at equal distances. Right? So 1, 2, 3, 4, 5, something like that. So they would be at equal distances. So we can find out their exact orders also, but they would be certainly equidistant. So that is the whole point. So I hope this is clear. So the number of meetings and their positions depends upon the speed ratios. Yes, equidistant also. There's some break in between, some add in between. Wait. So yes, equidistant also. Let's see the same thing again. See, in this when they were moving in the same direction, what was happening? When they were moving in the same direction, so what I said is, let me use this green color, yellow. So when A has traveled 3 complete rounds, in that duration, can you tell me B kitne round chalega? What is the distance traveled by B? That will be 2 rounds. It is because of their speed ratio, isn't it? So so A has traveled 3 rounds and B will travel 2 rounds, and that is the moment when both of them are reaching the starting position again for the first time, right? उससे पहले दोनों साथ में starting position पे नहीं पहुंचेंगे. This is the first time both of them would be reaching the starting position together, right? And at this moment, what is the difference between the distances traveled? So 3 rounds minus 2 rounds, that is 1 round. That means by this time they have met only once. So that's why I said, so in this scenario, they are meeting only once at only one distinct point, and that one distinct point is the starting position. They are meeting at the starting position only, right? Whenever they are meeting, they are together, they are meeting together at the starting position only because of their speed ratios, the difference of their speed ratio, that is 3 minus 2, that is 1. In this case, again, speed ratio is 3:2. So when A is traveling 3 rounds, So B is traveling 2 rounds because they are moving in the opposite direction. So in this case, sum of the speed ratio is to be considered. So sum of the speed ratio becomes 5. The total distance travel becomes 5 rounds. So by the time when they reach starting position again, when they are meeting at the starting position again, so together they have met total 5 times, and this was their 5th meeting. So the other meetings are happening at equal time intervals and equal distance points also, equidistant points also. So we can easily figure out कि कहाँ पे meet किए होंगे. Let's figure out that also. So this is the 5th point, and I'm assuming these are the points. Right, this was not the first point necessarily. Okay, now let's count first meeting point kaun sa hoga. See, let's count from this one, slower one. So it is traveling 2 units, 1 2, and it is traveling 3, 1 2 3. So this was the first meeting point. We had already mentioned that, right? So 1 2 and 1 2 3, this is the first meeting point. So just look from the point of view of the slower one. So 1 2 first meeting point, 1 2 second meeting point, 1 2 third meeting point, 1 2 fourth meeting point, and 1 2 fifth meeting point. We got all the meeting points. Is it okay? So that's how we can exactly find out the meeting positions also. At what point they are meeting for the 3rd time or 4th time or 2nd time or 1st time or 5th time and so on. Is it fine? I hope this is clear. So we could have done the same thing here also, but by the way, the values which we have taken accordingly, we are getting only one meeting point, and that one meeting point is the starting point only. I hope this is clear. So 5 meeting points, and where are those meeting points also that we have identified? So they are all equidistant. So we are equidistant होने का मतलब ये नहीं है कि they are being achieved in the order only. 1 2 3 4 5. No, this is the first meeting point, 2nd, 3rd, 4th, and 5th. That is the order here. Is it fine? Ashan is asking something. Yes, Piyush, that suggestion you can give to your iQuanta team. I'm always available there. Okay, let's move quickly to the solve our questions based on this, so that we can finish the session. Okay, please answer this one. Let's do it together only. At least read it together. Aman and Rohan are running in a circular track with speed 20 and 25 respectively. If they start running from a point O on that track in same direction, they are moving in same direction, then find the number of distinct meeting points. It's a very simple question. Please quickly answer. Please answer quickly. Yes, excellent. That's true. See, we just need to see the speed ratio. So speeds are 20 and 25. So 20 and 25, the speed ratio becomes basically 4:5. So because they are moving in same direction, so we just need to take the difference of that. So there's only one meeting point. Good. Let's move further. Achha, listen. If in place of same direction, if I change it to be opposite direction, now tell me the answer. Now tell me the answer. Piyush, that's correct. 1 point, and that too starting point only. Good. But now if they are in opposite direction, then please tell the answer. Excellent, Ridhima. Good. 9 points. And I'm sure now you can figure out the order of those 9 points also. Isn't it? If question asks you, बताओ second time कहाँ meet किया था, third time कहाँ किया था, fourth, fifth, sixth, and so on. So you can figure out the exact meeting points also, exact positions also. Excellent, excellent. I'm really glad to see so many correct answers here. That means you are all alive. Good. Okay, let's move further now. Okay, one more question. I think this is the last one, perhaps. Yes, Riddhima, dividing the circle into 9 equidistant points, and not only that, we can figure out the order also, in which order those 9 points are being achieved. Okay, right now answer this one. In a 4,000 meter race around a circular stadium having circumference of 1,000 meters, the fastest and the slowest reach the same point at the end of 5 minutes, at the end of the fifth minute for the first time after the start. All runners have same starting point and each runner maintains a uniform speed throughout the race. The fastest runner runs at twice the speed of slowest. What is the time taken by the fastest to finish the race? Okay, Piyush, you haven't understood that yet? Okay, I will discuss that, don't worry. But first solve this question. First answer this question, then we shall discuss the order of those meeting points also again. Haseeb says D. 5 minutes. 5 minutes में हो जाएगा क्या पूरा? It's not the correct answer, I guess. Kanishk says 10. 10 minutes. Okay, let's see it now. It's very easy question actually. See, this is the important sentence. It says if the fastest runner runs at twice the speed of the slowest runner. See, in the whole question, only consideration is about this fastest and the slowest runner, right? The other runners, if there are any, they're not being talked about. So let's forget them. ठीक है ना? So now fastest and slowest का the ratio of speed is 2:1 and they're moving in same direction. All are moving in same direction. It's a race basically in a 4,000 meter race. So race means of course they are moving in the same direction. It is not clearly mentioned although, but it is a race. They are running in a race. So they are moving in the same direction of course. So they are running in same direction and the speed ratio is 2:1. So speed ratio 2:1 in same direction. So that means they are going to meet only at one point and that one point is nothing but the starting point, right? They are going to meet at starting point. That means when A has traveled 2 rounds, the fastest one has traveled 2 rounds, the slower one has traveled only 1 round and they are meeting at the end of 5 minutes. So at the end of 5 minutes, the faster one is traveling 2 rounds. 2 rounds travel karne mein it is taking 5 minutes. Yes or no? That's what is happening. The faster one is completing 2 rounds in 5 minutes. And how many rounds he needs to cover? He needs to cover 1,000 meter circumference wale 4 rounds he need to cover, right? He needs to cover 4 rounds. So of course he is going to take 10 minutes. That's it. Done. That was the question. What is the time taken by the fastest runner to finish the race? It is 10 minutes. Nothing to solve, nothing. It's 10 minutes. Is it clear? So what we did, let me tell again. So we just observe this thing that fastest runner runs twice the speed of the slower one. So the speed ratio is 2:1. Fine. So there is only one meeting point for them. That is the starting point. So that means, so when at the end of 5th minute they are meeting for the first time. So by the end of 5th minute, both are meeting at the starting point. So by that time, the faster one has traveled 2 rounds and the slower one has traveled 1 round, right? So the faster one has traveled 2 rounds in 5 minutes. So faster one travel the 4 rounds in 10 minutes. That's it. That was our answer. ठीक है ना? अच्छा पहले हम उसका मीटिंग पॉइंट्स की बात कर लें. Let's take meeting points. In that previous question, we talked about the speed ratio of 5 and 4. Speed ratio of 5 and 4, and they are moving in opposite direction that we assume. So speed ratio of 5 and 4. And they move in opposite direction. So there are going to be 9 meeting points, isn't it? And 9 meeting points would be equidistant. So first let's make the 9 points. So yeah, this is the 9th meeting point that we know already. So बाकी सब equal distance पे मुझे बनाने हैं. तो कैसे बनाऊं? 8 पॉइंट और लगाने. मे बी ये 1 2 3 4 5 6 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, these are 9 points now. Is it fine? We are just trying to understand the 9 meeting points in what order they are being achieved. So they are starting from here. So the first meeting point would be where? So this person is traveling 4 units and this would be traveling 5 units. So 1, 2, 3, 4. Let me use a different color now. Let me use the white one. So 1, 2, 3, 4. This is the first meeting point. Because by this time, this person is traveling 5 units. 1, 2, 3, 4, 5, isn't it? So no need to count from both ends. Just take help of the one person, right? Just let's take help of the one person. So he has traveled 4 units. 1, 2, 3, 4, first meeting point. Then again 1, 2, 3, 4, second meeting point. Again 1, 2, 3, 4, third meeting point. Again 1, 2, 3, 4, fourth meeting point. Again 1, 2, 3, 4. This is fifth meeting point. Again 1, 2, 3, 4. This is now sixth meeting point. 1, 2, 3, 4. That is seventh meeting point. 1, 2, 3, 4. This is eighth meeting point. 1, 2, 3, 4. This is ninth meeting point. That's it. Okay, Siddhanshu is saying, sir, when the ratio is twice than the first, when they're running in the same direction, two people will meet before the starting point, right? Yes, that's true. That's true, Siddhanshu. That's what we used. Is this meeting point part clear? There's one more question to end the session. Siddhanshu, that's true. That's true. You're talking of circular motion only, na, Siddhanshu? Okay, Piyush and others, is that part clear? Meeting points on the circular track? Okay, good. Let's move to the last question to end the session. And here it is. Please solve it fast. And this is a good question. Sheila and Anshu are running in opposite directions on a circular track of length 120 with Sheila in clockwise direction. They start from point O with speed 6 and 9 respectively. Every time they meet, they interchange their direction and speed. They interchange their direction and speed. If they continue doing so, find out where they will meet for the 15th time. Very easy question. Please answer fast. Yes, Kopal, this is the last question of the session. Siddhanshu, when there are two meeting points, then they are diametrically opposite. There are two equidistant points on the circular track. As we did in the last question, when there are 9 meeting points, they are again equidistant. So whatever is the ratio, we need to check the difference between the speed ratios when the runners are moving in same direction. And we need to take the sum of the distance, sum of the speed ratios when the runners are moving in opposite direction. That's it. Okay, you can take this question as a homework question if you wish, and let me tell you the answer for this. The answer is not very difficult. Let me see once. This is speed 6 meter per second and 9 meter per second. So 3 and 2, 5 and 9, 15. This is the starting point. They are going to meet at starting point O. So that is the answer. So you can try to figure it out, and if there is any difficulty, you can certainly. Your starting point is the right answer. Yes, Dhananjay, that's correct. Yes, Riddhima, Nandini also have mentioned. Good. So this is the answer. So we shall end it here. So I hope you like the session. You can certainly write the reviews if you wish. That would be a good point. Thank you. Thanks for your so much time, so much patience, so much effort. So we shall end the session here. So we have discussed the whole time space distance in the span of 3 hours, and we have touched almost all of the topics all of the basic concepts here. Yes, Rutu, certainly. The same topic is being repeated many number of times. Not only in live classes, you have application classes, you have practice sessions, then you have crash course also, you have marathon sessions, so many things are there. So right now we have covered the entire topic of time space distance in a span of 3 hours. Yes, this was certainly like a marathon only. Yes, Piyush. Good. So here it was a mix of the all crowds. There were some new students also. There were some students from the previous batches as well. Riddhima, you want me to decrease the speed? In the comments, I saw many were wishing for increasing the speed. Anyhow, my purpose was that the things must be clear to everyone, and that's what I tried my best. Okay, shall we end it here? Yes, Nitin, what do you want to ask? Okay, so those who wish to leave can leave. So I will be just checking one or two more questions or doubts if there are any. Nitin, this is a question for you. This is a homework for you. If you have not yet solved it, so please try to solve it. And then you can ask your doubt if there is any. You can ask for the clarification on the group. Fine. So I'm leaving it for you to solve. We have discussed the whole theory part here. There's nothing new. There's nothing new to be told here. पीयूष ट्रेन टाइगर वाले में भी अच्छा अप्रोच लगा आपको, धन्यवाद, नाइस. Shasya, that calculation was 1:11 basically. The speed ratio was 1:11. So तो क्वेश्चन था कि कितनी स्पीड एक्स्ट्रा है, तो 10 एक्स्ट्रा हो गई ना, 1 and 11 में 10 एक्स्ट्रा हो गई. So 10 is how much percent of 1? That is 1000%. I repeat, 1 and 11 was the speed ratio, तो कितनी एक्स्ट्रा स्पीड है? That is 10, right? 11 is 10 more than 1. तो बट अब जो 10 है, वो 10 is what percent of 1? That is 1000%. That was the thing. Okay, thank you everyone. So Rutu, that depends upon your scheduling, so don't worry. But as I said earlier, hold all the topics, not only this one, all the topics are being repeated many number of times. So you are not going to miss anything if you are sincere. So just be sincere. Okay. So I shall take your leave now. Thank you very much. And we shall meet again soon in any of the next session. Yes, you will be getting your assignments and all. Be in touch with our iQuanta team. Yes, Piyush, certainly. Certainly, I will be getting something. There are many faculties, na, basically. So certainly, I would be also getting something. I don't know what topic or something, but certainly, I would be getting something. Okay, thank you everyone. Yes, of course. Yes, I've already answered that. Rutu, this recording is there only in the YouTube. Fine. After this session ends, then you will find the recording here only. Yes, thank you everyone. Thank you everyone present here.